Bom dia a todos, sejam muito bem-vindos ao Bioplastics Brasil, seminário internacional.
This is the international seminar about the compostable plastic material. Sometime more than that, it's a long time that the regard concerning the institutions is completely changed, the consumers as well. So we will be more selective and aware, and the advancements of the plastic material in the life does not mean to be an option. So we're trying to balance in terms of life quality and the possibilities concerning plastics, using bioplastic in the manufacturing of some products. As the name says, it's a set of material which is complex, so it's difficult to specify, and it takes to several opinions, mainly the opinion makers, being part of it. So this event is to make clear to the market what we have to do concerning plastic and the demands we can expect, and the standards, technical standards, and the ways of processing, use, and the news of the sectors, in order the Brazilian market can follow the world's trend in terms of plastic and renewable products. So the commitment of the companies in sustainability and the option of using these possibilities is here to, they are here to stay. So Ativas Brazil, Additiva Bioelements are our sponsors, Braskem, ERT, Technologies, Futamura, Piramidal, and Pertol Protitech and Packer. We thank the speakers, moderators, the speakers and the moderators and people that are taking part in this event. We are supported technically by Associação Brasileira de Produtos Compostáveis, so Composting Products, Brazilian Association. And also I am the editor of a magazine that is focused on this theme. Now I invite luciavalverdes, Director of Markeplan.
Good morning, everybody. Welcome. It is with great satisfaction that we are holding the first Bioplastics Brazil Markeplan in its 18 years of existence, has always tried to take to the public knowledge and innovative experience through its events. Bioplastics Brazil is the accomplishment of both goals of our company. This seminar was idealized by Ms. Ellen de Souza, chief editor of the Industrial Plastic Journal, and today our master of ceremony. We also have the technical support of BIPON through Ms. Carolina Daruti, executive director of the institution. We thank the contribution of Ms. Ellen Karina, fundamental in the execution of the contents of this seminar. Together, we try to gather experts and companies that will present with due knowledge the objectives of seminar. Our expectations of public exceed the initial expectations. We had more than 1,700 enrollments, and I'm sure that we're going to be satisfied with the results from today. Our thanks to the sponsors, supporters, lecturers, moderators, team from Markeplan, and support reps, and the participation of the participants who believed in this event. We wish a nice event to you all. Thank you very much, Lucia. And before starting the first panel of the event, we tell you that after the third panel, we'll make available a link in the chat with a registration form and an assessment for the emission of certificate. All of those who fill out the forms will receive a certificate by the mail that they have included. We remember that your comments are very important for us to improve the content of the event so that it can meet the expectations of everybody. I'm going to call now on the screen moderator Rusca Redolin, president of Abicon, and Furamura, and lecturers from panel number 1, Concepts and Norms on Bioplastics. Lecturers of this panel are going to be Kim Fabri from ERT, Julio Arada from Plastic Experience, Leonardo Serati from Additiva, Philippe de Wolfs from TUV Austria, Österreich, and João Carlos Godoy from Abicom, and Alex Ricardo Duarte from Braskem. Now, I give the floor to the moderator, Verusca Regolin, president of Abicon and Futamura. But before, I'm going to introduce Verusca's resume. Veruska is graduated in foreign trade and has a graduation in international business. She's been working in with Tamura for 17 years, and she's been engaged in the area of sustainability, working as sales manager for South America, presented a whole line of sustainable products of the company. She's participated in creation of ABICO, Brazilian Association of Compostable Biodegradable Polymers, and today she is directly helping the dissemination of knowledge and information about biodegradable and compostable products. Please, Veruska, you have the floor.
Ellen, good morning, everyone. I've been introduced and we have the president of Abicon supporting this event, and we work on sales area as well. It's an honor being part of this event as a mediator of so many important speakers. I would like to thank the organization of Bioplastics and luciavalverdes for the opportunity of Markeplan to be here with you, taking part in this event. Quickly about Abicon, it's an association focused on giving incentive to the development of biopolymers and composting in Brazil. And the focus is also promoting the valuation of the composting plastics via the composting. And we set v- small and medium business companies that use the biopolymers, biodegradable and composting, and all the interests that are part of this chain concerning waste, organic waste. So service renders of the sectors are associated to us concerning resign, packaging, and also composting. This is a cycle of circular economy. I invite you all to follow Abicon in the social media, and we are here for your questions. And if you want to be an associate, you're just adding your possibilities and helping us to be stronger. So we have a very important day with speakers that will clarify a lot about the theme. We will start with Kim. Send your questions and doubts. We'll be here organizing them. And the end of the presentations will be in the Q&A in a panel to clarify the doubts. Have a good event. Thank you, Veruska. Now I'll introduce Kin Factories of Rio T that will talk about the main challenges and opportunities that we have in Brazil to expand the use of bioplast. He's graduated in the business administration in Paraná University and also in RGV Rio de Janeiro concerning special projects. And he is also a a part of Dom Cabral Foundation and focus on biopolymers. He is acting now in companies abroad and starting here in the first biodegradable usine in Brazil. So
Say how important this event is for our sector. The more we make information known, the more we make the population know things, the better we'll inform and build a growing market. I would like to congratulate Veruska. I had the pleasure of working with her at Abicon. The work she's been doing at Abicon is essential. It is fundamental for biopolymers, for our industry. She's been doing a sensational work there. I'm gonna share my screen with us, with you, and then we'll start. Well, our main objective here is to talk about the bioplastics market, the main challenges that we see here in Brazil and in the world, but also the main opportunities. I think that is every big challenge offers a big opportunity to grow, and bioplastics are becoming the leading roles in the world of plastics. So all of us who are here, we have a mission. We believe, we have a conviction that the world needs to be improved. We have as our goal to really change the way we relate to our waste, to develop new technologies, to develop the we're raising, to develop a consumption habits that are different. We need to change paradigm. We have to be the agents of transformation for the world. And let's all agree that this image is not sustainable. It is something that is aggressive, something that has to be changed. And we all here have a mission to generate something new. We have a mission of getting into this market, of developing solutions so that this is increasingly rare for the generations to come. In 2019, we produced 360 million tons. In 220, we are in 400 million tons of plastic, and most of those plastics end up in dumpsters, in landfills. Out of this great quantity of produced plastic, 40% of those are single-use ones. So they come, are developed, serve, serve a purpose. That's not so that's noble, but in a short time they are discarded and remain in the environment for many, many years. So it's the time to act is now, really. We here, we as individuals, as companies, we have to act, we have to change, we have to rethink the way we see our materials and believe in a truly circular economy. I think that circularity, the true circularity, has to be part of our daily lives, and we have to see plastics differently. We have a motto here in ERT that we have to reimagine plastics for a regenerative world. We truly believe in green economy. We believe in the renewable sources, plastics that can be composted. So, as an objective, we have to believe in the circularity. We can always have this video, which inspires us greatly from nature. And here, in its DNA, in its essence, nature has circularity, respect for environment. That's why we work as a company, as people, to make this world more circular, more a greener one. So we believe that bioplastic is part of solutions. We always say that is a complementation of solution. They're not going to substitute all plastic. They didn't come to solve the world's problems, but they will no doubt be part of the solution. They are part of the solution. They are gaining market. We have many lecturers, many people that know a lot of the topic to show that bioplastic really came to stay. It is a technology that is constantly evolving. It's a relatively new material compared to conventional plastics, but a material that has exponential technological development. The bioplastics that we used to know 10 years ago, nowadays they have a performance, a capacity that is a productivity that is a lot superior than what we used to see 10 years in the past. So that's the way it goes. Bioplastics, no doubt, are the evolution of our renewable plastics, without any doubt. But as any big opportunity, as we've said, we see still some challenges ahead, not only in Brazil, but also in the world. The first biggest challenge is for the bioplastics, talking more specifically of PLA, the market where we work the most today, is scalability. Today, there's still a restricted offer of materials in the market, an offer that is gradually growing. It's estimated at 9.1 of annual growth to PLAs, 9% until 9.1% till 2026, led by some companies, no doubt. Carbon announced a big plant. We are here in the RT are working towards growing our productive capacity. So we see a big commitment of the industry as a whole to grow this capacity, to grow this scalability, to more and more being able to deliver more materials to the market and more allow those companies to make the change into compostable plastics. And no doubt, this is totally in line with cost. Today, PLA is still uh, more expensive than conventional plastics at a value that when ERT started in the past, you know that we have diminished this gap. In the past, we'd say that PLA didn't exist and was too expensive. Today, no doubt, the material is available in the market already. It has an industrial scale on the market, the availability of raw materials, but the price is starting to lower. Today, we see a ratio around 2.5 to 2.8 to PLA, and twice for PBAT. That is gradually diminishing the gap, and we believe that with increase of the cost of oil, with the technological development of PLAs, with increase of capacity, that gap is going to diminish more and more, and they will perhaps possibly converge into a similar. The market is still small compared to the global market. It is around estimated 10 billion US dollars, but it is growing, as we've been saying. It's been receiving investments and becoming a leading actor in the industry. We estimate that till 2030, 40% of the market of global market of plastics will be in the hands of bioplastics. Once again, it's going to be in the hands of a complementarity of solutions with bioplastics. There's a family of bioplastics, but that increase if our proportion of the general market will no doubt happen. Here we have two charts that I believe are interesting, and they show especially the market per country, the regions. What are the regions that grow the most? No doubt the US and Europe and Asia are the leading actors in this growth, pretty much motivated by the legislation, pretty much motivated by the awareness raising, education of population. I believe that this is why it's very important that we here in Brazil should continue to talk about that more and more, to stimulate more companies, and for the companies to feel more responsible and to deliver sustainable materials to the market through the voice of the population, through the new generation that no longer accepts conventional plastics for simple applications, for banal applications for the daily life. Bioplastics, uh, uh, they demand the bioplastics as the solution. It's nice to see the chart here in the world that Brazil, even though it's not at a great above 9, it is close to 9. It's at 80.7. ERT, we came to Brazil not long ago. We were positively surprised by the market, not only with the market that has been consuming, but it's been we've been surprised by the initiatives of Brazilian companies of local, small, mid-sized, large-sized Brazilian companies that have this will, this desire, this commitment to migrate into compostable plastics because they see that this is the path they have to follow. Not only commitment through legislation, but also commitment through moral commitment that the companies have in the environment. And the greatest growth of bioplastics is into packaging. Packaging is already the main application, and it's going to continue growing. It's going to continue becoming a leading actor into the bioplastics. And we have some mandates. The mandates are ending, mandates 2025. We either a reduction of carbon emissions or uh, change to uh, change into biodegradable, recyclable plastics. All those factors make us not only deliver more sustainable materials into the market, but also the companies being more and more committed with those solutions. And why does ERT believe so greatly in Brazil? We, when made the decision of coming to Brazil, investing in foreign resources here in our country, we, an American company, but we have as a board of directors, great part of them are Brazilian already. We see that Brazil is no doubt going to become a leading actor in the bioplastics market. Bioplastics market is basically derived from sugarcane. Brazil is the greatest producer of sugarcane in the world by far. Not only does it have the biggest production, the biggest cultivated area, but it also has the greatest ratio of cultivated area by produced ton, which demonstrates that Brazil has lots of technology, lots of people that know how to do it well. We invest strongly in technology, not only on the part of cultivation or handling of the land, but also in the improvement of those cultivars. We see scientists working strongly in the part of increasing productivity of our cultivars of sugarcane, and we've been the leading actors in the ethanol second generation, which demonstrates how capable our scientists, our companies are of improving and increasing those that simulation to new products, new technologies in the area of agriculture. Um, in addition to being a big producer of cane, we preserve our forest. We preserve nearly 60% of our environment. We have good programs, forests, areas of permanent preservation. So we believe that we have to invest strongly, we have to invest strongly on increasing our productive capacity and preserving our forests. That there's a philosophy and the company, especially in our company, and I live in our companies in Brazil too, that Brazil has to use its knowledge um, in growing industry and stop being a mere exporter of commodities. We have to invest in exporting technology. We have, at the same time that we protect our natural resources, we have to broaden our borders, exporting technology, added value products, sustainability. So why not looking into Brazil and the next 10 years? We saw the commitment from COP26 to transform into really transferring the fossil-based economy into a renewable one, and to transform Brazil in a big producer of PLA, of bioplastics. We have total capacity, we have total technology to make Brazil cease exporting just sugar, cease exporting just one commodity, and really start exporting a polymer, to start exporting a material that not only has lots of added value, but is always good for our environment. And that's where we get to the ideal scenery that all of us would look for, and that the company we are, our ERT, have been invested into, and we see this as our future of the bioplastics. This is going to take us to uh, we non-crop and non-food future. We produce PLA first generation based on sugarcane, but the future is non-crop, non-food. It's going to come with process derived from an agro-industrial waste. So Brazil still produces lots of agro waste. There are some places of concentration, but some places that we have big opportunities for us to make the sugarcane bagasse into a polymer of extremely high added value. So working with lots of knowledge and dedication, we arrive, we take our market into a market that is going to come from an agro-industrial waste and end up into a second generation polymer. I think that as final words to close, what we believe in, no doubt, Brazil is becoming the global market of bioplastics has been growing with lots of strength, and Brazil, together with the development of those technologies, is going to become a leading actor, and we're going to see Brazil exporting first generation polymers. We're going to see Brazil exporting in the second generation polymers so that we can deliver more and more better solutions, more sustainable solutions for the environment, for our home. We say that our home is our greatest asset and we have to protect it for our future generations. So that's it. I'd like to thank you for the time, and I'm open to questions at the end of this panel.
Thank you very much, Ken. And now we will go on to the presentation of Julio Arada, a speaker that will deal on what's bioplastic or what are bioplastics. Graduated by USP in industrial engineering, focused on plastics and Hope that the main institute on the subject, and also foreign trade by UNIP. And he is a professor in the Technical School of Plastics in Senai and former professor in Julio Gomes University, was a gerent of Monsanto S.A. and service in other companies, including BASF, and also wrote books about management. And he's a consultant, he's a professor concerning raw material and the University of São Paulo and the SP Society of Plastic Engineers in Brazilian institution, and also what we call the Brazilian Institution of Polymers. And also rendering services to Oswaldo Cruz Institution. He is a member of the Brazilian Association of Polymers and also a developer in the Brazilian section of engineers concerning development. And he is one of the managers of a platform of plastic experience. Good morning, everyone. Thank you very much for your introduction. I don't recall everything that you told about myself, but I agree with it. Okay, I did a summary. Okay, it's very complex, my career. Now, I'll carry on with data that Keen has already told us about. So what I have in my presentation, I'll go directly to some points like opening my computer. Let's find what I have to use. There's a PowerPoint. I'm sharing the screen. Just a sec. Technology is faster than I am. Can you see it? May I carry on? Okay, give me some feedback. Is everything all right? I have no response. Okay, I'll talk about bioplastic in this international seminar about plastic material compostable of renewable source. What are we focusing on? Sustainability that the human being and the earth require. Use screen. Use full screen, please. Use full screen, please. I don't know how to do it. Share again, please. That's what we have to do. Start again. So, start again.
Agora vamos. Agora sim.
Nada.
Okay. Let's check. Now, change to full screen. Full screen in your PowerPoint. It's complicated for me. Full screen, okay? Yes, it's perfect now. Thank you. Carry on, please. So we talked about the seminar and what's the definition concerning sustainability? The human being, we have to focus on sustainability because we are taking a direction that will simply will have human beings extinct on the earth. So the economy involves, of course, financial return, ecology, and social responsibility are key. So we have to do a deeper study considering the evolution of the modern civilization. So 1850 onwards, we had in this short period the population that doubled on many folds. And so it means that the 8 billion inhabitants and the resources we have in terms of energy, we need them. We are looking for energetic source, energy source. We started with wood. Okay, but of course it became scarce. Another energy source was carbon, mineral carbon. So we transformed it in, we have carbon plus hydrogen, and we're looking for solar, sun, wind, hydraulic, hydrogen, and nuclear. We're looking for energy. We're looking for an energy revolution. So quickly, the management of the carbon cycle in the ecosystem presently. So after the 50s, it's been used, and the noble material at that time, I believe in the planet, it is what's noble is what's sustainable. So we have, in this case, erroneously saying that plastic is not needing any resource. It is in our modern life, and it needs resources. So petrol, oil, millions of years we are transforming it, and plastic, what we see, if we dispose it, and it's not biodegradable, it will be here for many years in the nature. So in nature. So the biomass is essential, and the vegetable and animals being involved. And in the middle of this way, we have to consider what we're looking for, alternatives, biomass. Biomass, and then we're talking about biochemic industry. What we have here is it a balance over the 180 days, 100 to 20, 200 years. Could we put it shorter, a shorter time? What's made in 180 days takes 100 to 200 years to disappear. So what we're considering a standard in terms of sustainability is a new technology, which is carbon that is available and the time of production has to be considered. We are looking for technology that is behind all that. It is not so simple. What are we talking about? We are talking about challenges, about plastic, biopolymers is the raw material of a renewable source. So we have here the original product that's necessary in a certain percentage to be used in a relevant position. Fossil or more 50% renewable. In my opinion, it is 50% renewable, the polymers. And renewable is a reference in the raw material that is renewable, like corn, wheat, bacteria, and so grass and sugarcane, potato, manioc. Sustainability that we are using as our focus is a generic term for presenting viability of a product in the long run in the market. So that's the definition we present. So concerning disposal, terms used for disposal, definition, say, is it garbage? No. Garbage? No, it's waste. Because let us say we don't have space in the planet for all the plastic and material that we have around. So degradability, the process of fragmentation, so we have to consider the recycling, what can be reused, the degradation of the product via salt, oxide, metallic oxide, hydrodegradation, degradability via hydrolysis, and photodegradation, degradability via the light, UV. Biodegradation, by definition, degradability via microorganisms. What we mean when we say biotherm? What is it? Non-biodegradable and biodegradable. And so we have to analyze this picture, and we consider the biopolymers here. So we have the material of renewable source, sorry. So bioplastic, biodegradable, and compostable. And so we have PLA, PBAT, PBS, PHP, TPS, Quitosana, PBAT, PBS, PCL. And so we have the material at the biodegradable source. So biodegradable, what does it mean concerning polymers? We have aerobic and anaerobic. So we are here in the emission to the atmosphere. So you consider biodegradable and anaerobic in this process. What's aerobic? There is a control, there's a transformation of organic material in carbon dioxide. And so we have also water and humus in the presence of the oxygen. So the organic material, the biomass, and in methane gas, water, and humus in the absence of oxygen. That is an anaerobic. So we have to reuse the waste concerning CO2, water, and humus. So in the carbon cycle, we go from cradle to so what we have here in the whole process, I am referring here to the center of composting. And so when we talk about biodegradation, it depends on the application of the product. In agribusiness, for instance, we have the biodegraded material in water, so we have to observe the standards, ACS, TM 600, 6400, ASTM D6868, and other standards. So what does it mean, biodegradation? And we have consideration concerning temperature, humidity, and microorganisms. So you have this biodegradable material transformed a minimum 9% of CO2, 180 days, when you have this material that is biodegradable. And the waste, the biomass, that is the rest that is generating another way of evaluation concerning polymers. So the standard that we have for that is an European standard, and we also have the Brazilian standards. What are the conditions? They are standardized. It does not mean that I just throw plastic around the street and it is a biodegradable thing. No, no, it's very erroneous. We have to observe what happens to the material, the conditions to be transformed in biodegradable. Well, which are the points that are certain to check if a material is biodegradable? You see, if it's heavy metal, biodegradation. So the compostability is a test with the waste in the biomass to see if it's interfering with the growth of new plants. And I can also do the identification with C14 and C12 of the polymers. So we stop around here. Norms, generally, what I see, European one, EN 13432, and the Japanese one, and the American one that you see on the screen, but we also have the Brazilian one, NBR. So carrying on, biodegradable polymers, PBAT, EcoFlex F of BASF is biodegradable, and the base is K-polyester. It's not renewable. It's terephthalic acid, 1.4 to butanediol, and adipic acid. If you compare to PBAT, it's a material that's non-biodegradable. We have it differently here. So BPAT, Ecoflex, and its possible applications, sorry. We have a polyethylene that is, in terms of resistance, very low. We use it for use in the packing, the cling film, paper coating, and so we prepare also the bags that are disposed. Another one of a renewable source, PLA lactic poly, and that's the PLA, polylactic. So the synthesis of the PLA is on the screen. So it's corn glucose or sugar cane. And so I do my PLA. So it's a synthesis that's very complex. So we use it for textiles, several bags, types of bags using PLA, and also packing for cosmetics because it's more rigid than PBAT. So PLA is a material that's very much used. And I can also do some blending here. PLA, the bioplastics can be biodegradable polymers that are blended with using fossil sources and others. When we talk about this subject, we have many applications with these blends. We have the trays, we have flexible material, rigid material, and also the EcoView, which are what we consider green. Another use for this blend, PBAT plus PLA, is a result of combination of several properties. This is also a source for comparison with PP polyethylene. So PBAT plus TPS, what is it? It's a thermoplastic, so I use a combination of the properties. TPS, thermoplastic corn that is used, starch. In this case, we have the use by Novamont in Italy. So it's a starch, the material. So this is a PBAT plus TPS. We use it in EcoBras. It's a trademark. This material has other aspects to be used. And another material that is biopolymer and biodegradable is PHB and PHBV. We call it biocycle, and it's used by Quitosana. And here we have many biodegradable products on the screen. And there are some engineering plastics, we would say, that is a supply of biopolymeters. So we have castor oil, petrochemicals, fat acids, and coconut oil. And, and we also have nylon here. It's a biopolymer nylon. Another one that's very interesting is PPT, polytrimethyl terephthalate. In fact, this is a profile that we put here, and technically speaking, we call it G3. With this material is what we normally call engineering plastic product. So polyester, the origin of it is fat oil, but we also can use castor oil and sugarcane and corn. So biopolycarbonate, known biodegradable. And we have a new molecule that we have using by Mitsubishi polycarbonate, and the properties are very interesting if you compare to acrylic and other materials of fossil origin. So polycarbonate and other biopolemics are that cellulose, for instance, it's not new, it's one of the pioneers. And so cellulose, pay attention to this. So we have it in more quantity in our market as a biopolymer in our chain. So what's the reaction? This is the cellulose molecule that will place an acetate and or acetobutyrate and different types of basic esters. And so what's the biggest advantage? It is cellulose has a very pleasant space, let's say. It is less stability. So talking about properties and the present uses, for instance, toothpaste, if it's of good standard, is used cellulose, acetate, and also many toys, many glass braces and sport articles and toys, and even tools. So Letilena will not talk about it because I'm not an expert. So my question is to you, in 1 hectare, in terms of sugar cane, it produces how many tons of PE? So is it necessary to use sugarcane to produce polyethylene? I don't think so, because I think sugar is food, so we cannot put it aside. So if you compare to starch, concerning mandioca or corn, you have a composition to be considered. I have to go back here. When I talked about PLA, I use 1 hectare. Is it necessary? Does it justify the pain? In the past, we did not consider that, but now we have to. So limitations of the renewable sources that have to be used more specifically for biopolymers. And so the renewable sources are for food. And so it's growing and growing, the necessity, so we cannot put it aside. So that's my feeling. Now, 10, 20 years ago, I did not think this way, but technology has improved and we have to think about it and consider a new way. So recycling. So what we have, I won't go very deeply in the subject because I may be against my own personal thoughts. So we have to see what's happening all over the world concerning this subject. And I thank you very much. On the screen, I present the size of the market, but I don't have time for that. So thank you very much. So I did not finish it, but I have to stop because my time is over. Okay, I'm sorry, and thank you for your attention. Mm.
If I have any other remarks, we still have time to get back to you. Okay. Now, thank you, Julio, for your presentation, for the clarifications. And I'll move on to Leonardo Cerati's presentation. The topic of his presentation is bioplastics and renewable sources, biodegradable and compostable plastics. Leonardo is industrial chemistry, graduated by the Federal University of Rio Grande do Sul with a specialization in petrochemical, with a specialization in polymers and coordinator of the Biopolymers Technical Committee of Avicom. Welcome, Leonardo. Good morning, Ellen. Good morning, public. Thank you, first and foremost, for the opportunity of lecturing here in such a big event that Bioplastics Brazil is holding. I believe it's a very important topic, and we have to develop it to make right knowledge available for about bioplastics and the real possibility there is of replacing fossil-originated materials by renewable materials and perhaps biodegradables and compostable ones, so that we can really stop this negative impact that our technological advancement is causing in the environment. So I'm gonna now we have the technology and we have knowledge becoming more and more known to get back to what we can be. So let me share my screen. Just a second. Okay, let me just decrease it a little. All right, so my lecture is about uh, bioplastics of renewable sources, compostable and biodegradable. So the agenda, first part is plastic. Is it an ally or a villain? The intermediate segment is going to be bioplastics as a sustainable alternative. We're going to talk about the concepts to really understand what a bioplastic is, what is biodegradable, compostable, etc. And the final part is going to be about biodegradable and compostable plastic, the types that we have, some of the many types, and the benefits that they can bring to our applications. So first here, I have a chart from the world, the yearly production of plastic since 1950 up to 2019. So we see a big growth between the 1990s to 2020. So it's a development of plastic in all segments. We see the first synthesized polymers were in the 19th century. Then there was a big growth in the 1940s because of World War II, and then later for packaging, for domestic use, for textiles as nylon, and then for automotive industry, etc. So it gets to a level of 368 million yearly tons in 2029 and 2019. And here I leave the question, is it a plastic ally or a villain? I don't think that plastic will ever be a villain because, as Julius said, plastic is the reason why technology got to where it is today. Example of the electronics in automotives that with plastic became lighter, safer, with engineering plastics, and also the packaging for foods that made it easier. And in textiles for shoes, I believe that plastic will never be the villain, but it is poorly managed, especially at the end of the chain. Most plastics can be recycled. This is really poorly used. And for example, here, I have a chart by tons of all plastic produced from 1950 to 2015. You see that 29% is still in use, but 71% has been uh, discarded already. And from the 6.3 billion that was discarded, we see that practically 78% is accumulated in landfills and in nature, or even in nature. And this is a waste of materials that can get back to the economy, to the productive chain. We see that almost 13% were burned and only 9.5% was recycled. So we have many opportunities of recycling plastics, either primary, secondary, mechanic recycling, tertiary with chemical recycling, which is a noble recycling process to make this material come back as raw material or intermediate material as or require fourth level uh, recycling for energy use. We can use the technology, close on the cycle from better management, either the companies, we as consumers, or governments stimulating this kind of proper discard. So here we have some impacts that we know very well of that inappropriate discarding, either for marine flora fauna or the landfills. The landfills can be more proper, but they are not a solution. They are just hiding this waste. So we have impacting pictures here. So understanding that dependence on fossil plastics, the fossil fuel sources are limited resource, and their extraction is established that it generates greenhouse gases that negatively impact the environment. So it's time to change it. So inappropriate discarding, we're going to talk about compostable bioplastics, but compostable bioplastics are not solution for littering, for for discarding of material. This is going to continue happening if we don't improve our management of residue. Inappropriate residue discarding affects the quality of soil, water, etc. And less than 10% of those waste is recycled. Many are the recycling methods, many are the technologies that we can use. Here, we have more shocking data. The quality of plastic in the ocean, estimated in 75 to 199 million tons. And this grows. And in 2016, got into water ecosystems between 9 and 14 million tons. Until 2040, this quantity tends to triple if nothing is done about it. And obviously, this has lethal effects in all marine life, either by the animals getting stuck in the plastics and dying, or by the ingestion of plastics. They end up coming to us. So in addition to the quality of the microplastics and the quality of the water that we consume, the marine life gets back uh, to our life. So the plastic that they ingested can get back to us and impact us negatively. So we go to a solution here, which is bioplastics. Started by what it is. It's a big name, but it's limited in three items. Uh, Biodegradable plastic that has the susceptibility to biodegradation. Those are polymeric chains that are susceptible to this kind of phenomenon. Renewable plastics that comes from renewable sources, and the best of the both worlds, plastics from renewable origin and biodegradable concepts now of what are plastics. Those are polymers, macromolecules, organic macromolecules that have carbon, hydrogen, or nitrogen, or chlorine, like in PVC, that can be moved, and they can be synthesized from fossil origin, which is non-renewable origin, like oil, natural gas, carbon. And the classic examples that we know of those polymers are polyethylene, polypropylene, PET, and PBAT, right? And renewable origins, we have renewable origin. What comes from plants, for example, that is yearly renewed. The biobase that comes from biomass, from corn, potatoes, sugarcane, beets, wheat, etc. Those are examples of polymers synthesized from this kind of source, the PBS, biopolyethylene, and they're the ones derived from cellulose. The source doesn't mean it's going to be biodegradable. So the source does not mean how it's going to behave at the end of the chain. Polyethylene can be obtained from sugarcane, but it can be from renewable source. But the polymeric structure does not allow it to be biodegradable. Here, concepts of conventional plastics that are chemically inert for a long time, the 50, 100 years in nature. So those can be recycled. We can make use of the characteristic. Uh, but when they are discarded incorrectly, they remain there for decades. And we have biodegradable plastics, those that have a structure that is naturally susceptible to degradation by microorganisms that will, in environments with oxygen or environments that don't have oxygen, that are anaerobic, and the biodegradation is going to produce will produce water, methane, in the case of anaerobic, which is really that is harmful for greenhouse gas effect. But in case this is captured and used, this is an alternative. Another problem of biodegradable work is that it was taken as for materials that were not biodegradable. Let's say that the biodegradation of normal plastic is going to happen. Yeah, it's going to happen, but it's going to take a century. And this kind of naming was used incorrectly. So it does not mean a time limit for degradation to happen. So that's why we have to be somewhat sensitive and think about new naming a new kind of tests as the example of the compostable plastics, which is aerobic biodegradation with oxygen. So those are materials that are susceptible to aerobic biodegradation. Uh, that is going to happen in specific conditions of microorganisms, oxygen, temperature, etc. That is going to happen in another limit point that's going to be uh, established by norms. Because there is a point, no, there's no point in having a biodegradable plastic that's going to be degradable in 50 years. How is this going to be good for nature? So there is a limit time that is in compostation is like 180 days up to 50%. And that's what is important. Compostable plastic is going to be specified by norms that are going to have a criteria of approval, reproval, not only norms that are just a specification of tests. Those are norms that are going to talk about how the tests are made, and there will be criteria to approve or reprove those materials. Either or not they're composable. And there's a scheme that Philip is going to explain much better later. That is the scheme that we have the law, and we have certifiers that are they're going to certify those norms. They're going to certify the materials of one company according to the norm. Here, so here we have some examples of norm. Here normally they have stages of de-integration. That is less than 10% of material has to have size bigger than 2 millimeters in a certain time. That stage of mineralization, that is the conversion of this material into carbon dioxide, 90% in X periods of time. There's control of substances, which should happen in the formulation of this plastic, as Julio mentioned. There's no point in having compostable plastic if there are heavy metals in its formulation. So those norms, all those norms, they have negative lists or lists of certain limits of lethal substances. There's also the field behavior that is assessed. The plastic cannot have negative effect in the composting uh, process with organic materials and ecotoxicity. That is, the manure that is formed cannot cause damage to the plants because the object of the circular economy of a constructible plastic is to take them from renewable sources and then at the end of the chain get back to the renewable source as biomass. Here we have compostability certification, some examples of norms. AN 13432, that's the European one. We have ESTM 6400 from the United States. We have ABN NBR 15448.1-2. John's going to discuss about it. The next examples of seals and certificates that are possible from the composting biodegradation norms or bio-based renewable source norms, which are certificates. Philip is going to talk more to you about the seals too, from seals from TUV. Here, just a recap of what I said. That really is source, whether or not renewable, regardless of how it's going to behave at the end of the chain. So here we're going to have PLA, PHA, PBS, starch blends. They are from renewable source and have this characteristic of biodegradation. However, we're going to have PBAT, which is mainly from fossil fuel, but it's going to have this characteristic of biodegradation. And then we have polyethylene that is, can be taken from renewable source. It is fantastic to prioritize renewable sources, but there is no magic that's going to make that those ethylene, carbon, hydrogen bonds to have some cleaving and magically the microorganisms will digest those that kind of material to form manure. Up to the moment, we don't have it, but it's excellent that it may be obtained from renewable sources and obviously can be recycled too. Here are the types of bioplastics. We have natural polymers, which are those that naturally happen from plants. as an example of lignin, natural latex, polysaccharides, and we also have derived from natural origin. It is synthesized from a renewable material in origin, like starch, fat acids, etc. So here we have starch-derived sources that are renewable, biodegradable. There are two polymers, amyloase, amylopectine in different contents. Starch can be extracted from several sources, from potato, wheat, corn, several sources, since this is the plants use it as a source of energy, and they can be obtained. We can obtain several plastics for industrial use. And in the case of thermoplastic starch, TBS, that is obtained from the structuring of the grain, transforming the starch with thermoplastic reducers. And many starch blends can be made to meet several applications. Here we have, as you said, the cellulose-derived products, a very old biopolymer that is renewable and biodegradable, the main component of the cell wall of the plants, and they have chemical industrial processes that are carried out to transform it as film or fiber, and we know that there are many chemical industrial processes that can be carried out with products derived from cellulose. Here we have a very promising class of biopolymers that are biodegradable, which are the PEA, polyhydroxyalkanoates that are produced from microorganisms that digest starch, a source of energy, and produce this kind of material. So this kind of material can be taken from the cell walls of those microorganisms, and the PHB with polyhydroxy alkylidide. It's very greatly studied in the academia, and when we do applications in extrusion, films, extrusion, and it's promising for circular economy, especially because of this kind of different source of being also biodegradable. Here we have PLA, that is from biodegradable renewable source, one of the most commercially available biopolymers together with the starches. So is one of the most well-known bioplastics. It's three stereoisomers are possible, but we have a lactic acid from fermentation of saucers from sugars with microorganisms. And this material appears very well in industrial process because it has right rigidity, it has good plasticity, fusion temperature that is low, which make it easily processed in uh, the equipment that normally processes polyolefins. It's biocompatible, bioabsorbable. There are several applications for medicine that are quite promising. Some benefits and applications. Why are we going to use the bioplastics? As I said, the burning of fossil fuels is a great contributor for greenhouse effects. The impacts of inappropriate discarding is devastating, and conventional plastics should be separated from organic waste so that they can be recycled. And the question that I leave to you, that single-use discardable plastics, why should they be made of materials that will remain for decades if not recyclable? Why should be so small, use minutes, seconds? You're talking about supermarket plastic, discardable uh, apparel or so how to use the bioplastic in the replacement of fossil origin plastic contributing for the circular economy. Regularly, we have to think about new alternatives. Even for those plastics that are non-compostable, we have to think about alternatives of removing them from renewable sources for applications in which the composting will add value. This is very important, for example, in the organic domestic waste, because it's possible to do it with compostable bags and the plastic and the organic waste directly to composting. Agricultural applications, there's more filmed agricultural films that can be biodegradable and replaced than plastic for single use. Here we have some applications. We see mainly in packaging here on the slide, but it's really several of the applications that we can have in medicine, as I said, with PLA. which is a quite versatile biocompatible polymer. And we have several studies which are quite promising regarding all the biodegradable biopolymers. Here we have uh, a positive outlook. This is the capacity of production or global capacity of production of bioplastics in 2021. That was 2.48 million tons. We have high PBAT, PBS, PLA, and starch plants. But we see a growth in the capacity of production precisely because of the expansion and initiative and the opening of new plants of PLA, like here in Brazil. Either the expensive number comes from PBAT, which goes well in blends with biodegradable materials, precisely because we can create different characteristics that can meet the different applications. Okay, and that's it then. I thank you all for your attention. I'm gonna go back to you, Alan.
Okay, thank you very much, Leonardo, for your participation presentation, very clarifying. And we'll now have Philip de Voogd's presentation. He is Belgian, and his presentation is focused on standards, tests,
Can I start?
technical
Okay, sorry.
norms,
Sorry.
apresentação do Philip.
I have no feedback, so.
Alguma questãozinha técnica. Philip, just a second, please. I'm going to introduce you. O Philip, ele tem formação em engenharia e ciência da computação e sempre trabalha.
Engineer, always working with the evaluation of conformity in the railway companies in the beginning of his career, and he's focused on bioplastics. He is the leader in Austria of this department, and also in 2017, he, via Active Austria, an organization of very important certificates, is a member of several companies dealing with the standards, and we are sharing his experience now. Welcome, Philip.
So good morning, and thank you for inviting me to speak to your event, and that's very, it's an honor for me. So I will try to not repeat thing already said this morning, but even if I will do it in English with other sketches and with the point of view of a certification body. And so as already asked today, what are bioplastics? And bioplastics can be biodegradable, can be bio-based, or can be both. Just maybe a few words about our organization. TÜV Austria is a certification, inspection, and testing body, and we are based on a non-for-profit association. And our main activity is to verify and to assess statements, in my case, for bioplastics. So if you have a look to the closed loop going from raw material to resins, intermediates, films, packaging, for example, this can be composted, biodegraded at home or in industrial facilities. And that during the biodegradation process, as already said, there is emission of carbon dioxide and biomass and water. And that carbon dioxide will be used by the plant to grow for the next cycle. So we have a very nice closed loop here. Nevertheless, it's sometimes necessary to add some additives, some components coming from fossil resources. When we focus on the right side of that loop, we are speaking about waste management, end of life. While we are looking to the left side of the loop, it's about the resources management, the origin of material. And you can see that there is no obvious connection between both. It's not because a product is bio-based that it will biodegrade, or it's not because a product biodegrade that means that it is fully bio-based. For each part, end of life of origin of the material, there are some certification schemes and standards. And I propose to go through the different definition and concept here. First of all, biodegradation and compost. Degradable is a generic term. Everything will degrade one day. But we can speak about biodegradation only when that degradation is performed, is made by living organism. Bio means living. So there is a lot of other way to degrade products, like UV light, oxygen, water, and so far, but this is not biodegradation. And what is really important to remember is that biodegradation must always be combined with the place, with the environment where that biodegradation occurs. And you can have the biodegradation in compost facilities, industrial compost facilities, or in your domestic compost, biodegradation in the soil, biodegradation in the fresh water, or biodegradation in the seawater. And for each of them, you have certification schemes, standards, and logos. What is important to say is that the most favorable place to have biodegradation is industrial composting. You have humidity, you have a lot of microorganisms, you have high temperature. And the worst place, of course, to biodegrade is seawater, and especially when the water is not that hot. When we speak about compostability, indeed, there are, as already said, there are four main criteria: the biodegradation, the disintegration, the absence of ecotoxic effect, and the limited amount of heavy metals. What is important to well understand is that biodegradation, ecotoxicity, and heavy metal are related to a material. It's a characteristic of a material, while the disintegration is a characteristic of a finished product made of that material. And it's quite easy to understand that. How thicker is a product, how more time it will take to disintegrate. And remember that biodegradation and disintegration are related to the environment where that process occurs. A few pictures about the different tests: biodegradation test, where we measure the carbon dioxide, the disintegration test, and the ecotoxicity effects. Now, going on the other part of the loop about the bio-based content. You already saw that scheme today, but I will repeat it. Biomass plants need carbon dioxide to grow, and the transformation of carbon dioxide into biomass is called the photosynthesis. If you have time enough and specific condition, you can create petroleum, oil. And that resource, that fossil resource, will be used by the conventional chemical industry to create polymer chemicals and fuels. This process takes millions of years. And our issue today is that we emit in the atmosphere in a very, very short delay, a few years, carbon dioxide used million years ago by plants to grow. And that's our issue today. That's the reason why we have that increase of carbon dioxide level in the atmosphere. Biochemical industry is indeed a shortcut, going directly from the biomass to the biopolymers without waiting millions of years, only a few months or years. And our activity, or target, or goal as certification body is to define, to measure which part in a product is coming from the fossil stream and which part is coming directly from the plants. And there are different standards to do that. Just take an example. Just imagine a very simple product. Total is 10 grams, and that product is made of 3 grams of PLA and 7 grams of polypropylene, for example. PLA is 100% bio-based, coming from starch, from corn, and polypropylene is fully fossil-based. So if we have to define what is the bio-based content, it's quite obvious. We can just take, just make the calculation and say that it's the 3 grams PLA on the total weight 10 grams, so it's 30%. And there is a standard defining how to define and how to measure and how to calculate that. But indeed, if we focus on the carbon, and it's our issue today, if we focus on the carbon, you have to know that PLA contains 50% of carbon, which represent 1.5 gram in my example, while carbon represent 86% of polypropylene. So if you make the same calculation, but only focusing on carbon, you have only 20%. And there are different standards establishing the rules, the criteria, and the way to calculate that. The difference is that on one side, we are speaking about bio-based content, and on the other side, we are speaking about bio-based carbon content. And once again, for each, there are some schemes and logos. We launched the OK Bio-based scheme in 2009, and we decided at that time to use to set up some limits, some threshold, and to have a, let's say, class approach with stars. So if you look here, we define 2 minimum values. The first one is for the carbon fraction. The idea was, I will give you an example. If you have a bottle made of glass with a small paper label, there is no carbon in glass. So glass is not bio-based, there is no carbon at all. But on the small label made of paper, there is some renewable bio-based carbon. And does it make sense to claim that the bottle with the label, the paper label, is bio-based only because a very small part of the product is bio-based? We decide no. We said no, this is greenwashing, creating confusion and misleading, giving misleading information to the consumer. So we decide that to be eligible for OK Bio-based, it was necessary to set up to have at least 30% of carbon in the product. On the other side, we said that it was necessary to have at least 20% of the bio-based carbon content. And depending the level of the bio-based carbon content, you have the different categories. 1 star for 20 up to 40%, 2 stars 40-60, 3 stars 60-80, and 4 stars is above 80%. So just remember that, for example, PLA is 100% bio-based and contains 50% of carbon. So it's in this area. I don't know if you see my arrow, it's in this area. These are the different technology for testing, and you have to know that we do not perform the test by ourselves. We are working with some laboratories, qualified laboratories. We audit and in order to check their quality. Already shown today, if on one side, you have the origin of the material, oil-based, fossil-based, or bio-based, and on the other side, the end of life, biodegradable or not. The first quarter is polyethylene based on oil, obvious, fossil-based and not biodegradable. On the other side, you have the PLA, for example, or starch-based products, which are bio-based and biodegradable. And then you have two different quarter, PBAT, for example, which is fossil-based but biodegradable, and very common in your country, polyethylene made from sugarcane, which is bio-based but not biodegradable. Beyond the aspect of assessment, when we some companies ask to be certified, beyond that assessment, there is a more and more important aspect is the communication. And in a few words, I will show you what is the, let's say, certification process going from the application. We perform an assessment. If the product is conform, we can issue the certificate. If not, we will ask for corrective action. Once certified, we will publish the basic information on the website just to inform the consumer, the authorities, and the other the stakeholders, let's say, that this product or this material is well certified, and depending for the different certification schemes. But what is very important is that we start at that time the market monitoring. That means that during the life of the certificate, we will monitor the market and see if the product on the market are accepted the same as the certified one. If there is non-conformities, can be up to suspension or withdrawal of the certificate. Our certificates are always based on assessment reports and on test reports. But you can imagine that the test reports are very difficult to understand, a lot of technical information. The assessment report is much more easy to understand, but contains still confidential information. And at the end, certificate and a logo are very easy to understand, but there is no technical content at all, except some information, for example, on which standard we base the assessment, for example. And so we can say that the conformity mark translates complex technical matters in easy to understand message by the end user, by the consumers. But as said, more and more, we are facing issues about the communication. And believe me, we receive not daily, but weekly, very strange application, companies willing to certify shoes to be OK compost home, or shirts to be biodegradable in the sea, and so far. And so we defined a way to classify the different possibilities and to define if a product is certifiable according to our schemes. And indeed, there are four possibilities. The first one is, yes, we can certify. Makes sense. There is no reason to not accept. The second case is, yes, we can certify, but we with some additional requirements, and usually these are technical requirements, additional tests or additional thresholds. Sometimes we have the we accept to certify, but with some restriction, and mainly about the communication. For example, we accept to certify, but we do not allow to put the logo on the product to avoid any confusion. And at the end, no, we cannot certify. And I would like to use 3 examples to show what are the differences. On the first case, we have shopping bags for fruit and vegetable. The second case is a protection for a mobile phone, and the third one is a tire. So the question for the first one is, do we accept to certify such a product being okay compost, home or industrial? And the answer is yes, makes sense. It's covered by many standards, it's covered by many legislation. That makes sense, of course. But we will never certify bags or packaging according to okay biodegradable, soil, water, marine, whatever, because that would give a wrong message to the consumer, to the citizen, just thinking that they can just abandon, just drop the product, the packaging on the beach or in the river, and it will disappear, which is not the case. Second, the mobile phone case. Shall we agree to certify such a product okay compost? And here, of course, it's a nonsense. Nobody will collect such a product. No composter facility will accept to compost such a product. But it makes sense to certify such a product okay bio-based. And how more you have bio-based carbon on the product, how more you will receive stars for that product. And the last one is tire. And here the question is the difference between finished product and dust or residues or particles. You have to know that the biggest part of microplastic in the sea are coming from paints, from textile fibers, and dust from tires. So do we agree to certify a tire being, for example, okay, biodegradable marine? Of course not, because once again, it's giving a wrong message to the users, and they could abandon their tire on the beach, which is it's a nonsense. But of course, it should be very interesting to have such a material being biodegradable in the sea, due to the fact that the dust, the residues of the tires are finishing that in the sea. But unfortunately, we have not yet found a way to communicate properly about that without creating confusion. So for the moment, we refuse such certification. I would like just to give you a very short information about the different level of certification. Just imagine here, it's a bag, a bread bag made of different material. You have a resin to make the film, transparent film. You have paper, ink to print on the paper, and you have glue, adhesive to assemble the different components. Each producer of the different constituent of this will can be certified. And then you have a company converting the raw material, the resin, in film. And we will deliver a certificate for the company M producing the film based on the information and test results coming from the company A producing the raw material. And the same, we will certify the printed paper based on the certificate for paper and the certificate for the ink. And at the end, you have a company assembling the film and the printed paper with the adhesive. And once again, we can certify the finished product based on the certificates of the intermediates. Usually testing are made at the level of the producers, and the market monitoring is performed on the product we find on the market, in this case the bread bag. And in case of non-conformity, then we will investigate and check who made the mistake. Is it the assembler using the wrong film, or is it the converter using the wrong resin, or is it the raw material producer changing, for example, the composition of its resin? So, in a few words, biodegradable and bio-based are two different stories, two different concepts, and being one does not automatically mean being the other. Biodegradation and disintegration are always related to a place where that occurs. It is not because a raw material is certified that any product made of that raw material is automatically certified. And at the end, a certification body give confidence in to the statements made by the different companies producing the different products. So that's all for today. I would like to thank you very much, and do not hesitate to ask a question or to visit our website, okcompost.org. Thank you very much.
Well, thank you, Felipe, the Wolf. Your presentation was quite clarifying. And now we're going to go to João Carlos de Godoy. He's from Abicon, and he's going to continue this discussion regarding norms. The topic of his presentations is international systems of certification for biodegradable bioplastics, compostable ones, and the importance of conformity with technical, international, and national norms. Hello, João, welcome. Let me quickly introduce you here. João is materials engineer from the São Carlos University. He is from Bioplastics, founded in 2014, and the technical director of Beacon. He is an expert of over 25 years in the area of development of new products, industrial production in plastics for engineering, biopolymers obtained from agricultural renewable source, and also compounds with natural fibers. He has technological base. He has broad experience in management of integration programs among universities, research search, technical cooperation, and for the development of new products in Brazil, the United States, and Europe. Welcome, you have the floor. Good morning, everybody. I would like to renew some expressions of gratitude on behalf of Abicon for this initiative organized by Party Plan in a partnership with the Industrial Plastic Journal, which has always been our biggest technical publication that has always looked with great care, with quite a criteria, look into the potential of the bioplastics. It's always given space in its publications for this topic. And obviously, this topic is very broad today. Today we've had a series of presentations that were focused on definitions, on technical norms that are something very important. Because what happens is that there's lots of false information in the Brazilian market, and little do we know about the practice of those questions regarding access to technical norms, access to labs capable of providing services of characterizations as per technical norms. And also a barrier that we have in the market is the absence of entities for the certification in the Brazilian market. So my presentation is going to consolidate the knowledge that we have obtained this far with all presentations, and speak a little about our Brazilian technical norm that has been developed some time ago, and also compare it with the other international norms that we have. What are those differences that we have between American, European, and Asian technical norms? Well, ABICON is Association of Industries that represents all the chain of value of bioplastics. Together with our members, we have developed positions, contributed for legislative processes around topics of efficiency of resource bioeconomy, circular economy management of residue waste and climate change. A very important role of bioplastics to eliminate the fossil sources because we know that oil industry has a very strong carbon footprint. And it is a new industry considered in the whole world as a young one. Has left its infancy because we are in the third or fourth round of expansion of investments in productive capacity, and they are considered, they offer the attributes that are alternatives to the traditional sources that we've been questioning, the implications associated to environmental damage and incorrect discarding. The advantage of bioplastics, no doubt, there is the carbon footprint because it can reduce those emissions. Also, our dependence on fossil fuels, and it expands the possibility of a recovery after consumption. There are many options of end of cycle of life, including recycling, biodegradation, and composting. Today, the members of Abicon are a group of companies, as Veruska described, which are part of this whole productive chain, and which obviously we dedicate ourselves in the last year, especially to redesign our bylaws, to define our objectives, to look for necessary coalitions, partnerships with other similar institutions of the sector, even with the plastic sector. And we are in the same productive chain. And this set of companies really put Abicon in a position that it can start to contribute for the development of this sector in Brazil. There are several systems of certification implemented all over the world. There is almost an overdoses of logos that have been used in the several types of products. Many of those are not of official certifying entities, and they have caused great confusion for the consumers who cannot interpret all this. But there is a very important characteristic that this family of polymers, PLAs, PBSs, PBAs, um, PHD, all those materials are or end up getting into letter 7. So we're there together with all the other types of plastic. The only thing that one consumer can identify, but for the recycling industry, this number 7, which means to several types of materials that are not the others, uh, creates a big difficulty for the recycling industry to identify and work it. Bioplastics are not easily distinguishable from common plastics, and it's necessary that we provide a mechanism that guarantees quality, labeling, the effect, these are the communication effect that the consumers and users can understand. Based on the normative standards that have been built for over 20 years globally, we have several technical norms that often have a matter of identification. They are analog, they are norms which are written differently but can be considered even in a reciprocal way. In Brazil, we have since 2008 the publication of the ABN NBR 1544.8.1 published since 2008 that establishes requirements and test methods to determine the compostability of plastic packaging, aiming to re-evaluate residues after consumption through is showing characteristics of the biodegradation after the integration and those materials and their impact in the composting processes. So the name of our technical norm in Brazil is degradable plastic packaging and or from renewable sources from all the technology that established the part one is the terminology and part two here are the tests and they have it has a questionable naming degradable plastic packaging and or renewable sources. Then has the second part that talks about requirements, methods. And in the United States, for a long time, we have a STM, which appeared almost a decade before the Brazilian norm. Uh, is specified directly. The name of the title, it is a norm to establish one specification for material to be labeled as a material that was designed to be anaerobically composted in industrial municipal processes in the cities. That is, as we have selective separation of compostable materials as we have in many cities in Brazil and the world, how can we identify that a material can safely go to a composting unit? How can we guarantee that this material is not going to cause a problem, it's not going to become microplastic, not going to become contamination in the composting process? We have ASTM D6868 that incorporates other materials which are added to the packaging. Inks, adhesives, combinations of paper with bioplastic coating, multi-layers, and the same way, it defines compostable bioplastic as a material that is degradable in biological processes that during the composting process can produce carbon dioxide, water, or some inorganic compounds and biomass or humus. There is a rate, a consistent rate compared to other materials, which are also from these characteristics, such as organic waste and leaves and materials tree, from trees, etc. Anyway, we have basically for text, we have a big reciprocity between our Brazilian technical norm with the STM. And we also have ISO, which normatize this internationally. That is, this is consolidated in an ISO norm is plastic organic recycling specifications for compostable plastics, which follows the same thing as it's been said. It's going to analyze the aspects related to biodegradation, the integration, negative effects of the process of a composting facility, the quality of the compound that is obtained, which is the result of the product that is a result of composting. This product has to have fertilizer most of the times and it cannot have any the harmful substance. And there are many things today, in addition to heavy metals, that can be in those materials. Also, the European Committee of Normatization also had for several times DIN 13432, which basically, and this is basically our norm is 98% based on this European norm, the Brazilian norm. It was a norm that was discussed for 2 years, coordinated by ABPLAS, ABNT, for several companies, and there is no need to reinvent many things. All of these was studied. And finally, we have the technical norms. We have the labs capable of providing service all over the world. There is a sturdy structure of laboratories which are certified by the certifying companies that list the laboratories that are capable of performing all the tests. And we have the strong presence of three certifying companies, TUV, Rhineland, TUV Austria, and BPI, each one following its regional norms, but working with the concept of reciprocity among norms. And there are things which are more specific related to what would be home component, biodegradable water, biodegradable. There are more specific norms regarding to this. Each country, basically, each area, the America are based on ESTM. Europe is based more on the EN norms, but there's a trend that in the future we should unify these all. In addition to the fact that those certifying companies are entities, they are third parties, they are companies that are exempt. You need to trust the certifying company. There will be confidential pieces of information which will have to be sent from each company to those certifying entities, which will simply analyze the data or prove the results that the labs obtained. In Brazil, up until now, we don't have laboratories capable of performing all the stages of those tests, but academically, there are many universities, the Senai from Rio Grande do Sul, several universities in Brazil, which use those technical norms in their research and development work. The Brazilian technical norm has been applied academically for research and development for quite a long time. So we have some experience about it, but we don't have our norm linked to any certifying entity in the world today. And we don't even have a certifying company in Brazil. Well, as many have shown, it is important to stress that all that is in the market for over 20 years. So consumers from many countries already understand those logos, even though there is still great effort of communication, even though there's a large quantity of fake products. There is a complicated situation regarding to this. But the seals exist for renewable sources, for whatever is industrially compostable, for what is domestically compostable, for biodegradable in the soil, for the effects of biodegradable in marine environment. It's important to mention that those tests of certification, which are carried out in the lab, they reflect they simulate a condition which happens in composting in real life. Composting is an industry. Composting is an industry, industry of sanitation or production of organic fertilizers. It is to have lots of care with whatever it mixes, but the process is very similar. If we see here this chart of how the composting process happens, we see that in real life, composting, looking here, we see an increase of temperature, which happens in the process, which is a direct relationship of the presence of microorganisms. The greater the population of microorganisms, which is digesting all that organic matter, rest of food, biomass, green materials, all that is mixed, even the packaging of biomaterial, we have an increase of temperature, which happens precisely because of this environment that is ideal, which is made available and of energy of food for the bacteria and fungi. And this happens at the thermophilic phase. So a great part of the biodegradation of the materials happens in this phase, which is a phase which takes a while. It can take something from 70 to 90 days. So there is no composting with smaller times than this. This is a natural process of which you create the proper environment for what the microorganisms to be able to do the biodegradation. The same microorganisms which are in the decomposition of an orange peel or meat or materials rich in cellulose. And at the end of the day, all those tests get to one conclusion, which is based on criteria that is approved or reproved. So not to repeat what many have already explained, the first phase is to study the biodegradation, to compare it with a standard that is known for cellulose. It's not that the material has to be totally deintegrated. First, the uh, uh, but the molecules have to deintegrate totally. It's not sufficient to break some parts of the chains. You know that polymers are very long chains, so it's not enough to break part of the chain. We have to break the molecules. That's why we compare with the standard of celluloses in an environment or with microorganisms, and we hope that the organic carbon is converted into carbon dioxide, the organic carbon that is present in the composition of the material. So this is the first stage of the test. The second stage is the integration. Oftentimes in composting, there are several materials which are not degradable so fast. Oftentimes bioplastics are biodegradable faster than an orange peel. Materials rich in lignin. An example of this would be in composting process in the soil, for instance, wood fibers that we call here wood fibers, ground wood. In composting, it takes 71% will take 700 days to be biodegraded. So we hope that the packaging can become biodegradable in less than 180 days. This is the objective. This is a material that cannot be a problem for the microorganism, but it's natural. Those are materials that are rich in lignin structures that do not become biodegradable fast. The same as if we this in the soil, we're going to have biodegradation between 50 and 70% only in a period that may vary from 1 to 2 years. So those are processes that naturally happen in nature. And from this, in the composting techniques, you work with several types of techniques for you to grind this material, to have to go undergo grinding system so you can improve surface area and facilitate biodegradation together with organic waste or residue. And here I'm going to catch the attention for a very important point. Even though all those norms, also the European, American, Brazilian norms, Japanese norms, they are very similar in their techniques, in their criteria, etc. We have differences here and there of heavy metals. The Brazilian norm, MBR 4482, is very similar to the American norm, so the European norm. So we are quite rigid at the level of heavy metals. Also, we're very similar to Japan, which is more has a stronger criteria, but we're a lot more careful than what is required by ESTM D6400 regarding that is the most applied in the United States and Canada, where they are a lot more tolerant to those metals. It is difficult to say that which one would be the best or the worst, but the fact is that today it's recognized that lots of those elements, many of those elements here that are called heavy metals, they are nutrients of the plant. They're nutrients for plants. So there's indeed the possibility of increasing those contents here of metals to meet products to get as per the American norm. So and Canadian has a small difference in some of the 11 chemical elements that many of them are metals, many of them are heavy metals. Uh, uh, that we're presenting this in milligrams per kilogram of dry matter. And in addition to those 11 heavy metals, and we have to be very careful with them, we know that today many of the paints, pigments do not have those metals anymore. And this is in concentrations, in waste and catalyzers on the biopolymers. So we have to be careful this, and it's up to IBCOM to define what would be the standard that we're going to use and how we're going to convince some global labs for some certification to carry out the test according to our Brazilian norm. But in addition to this, there are flowered like compounds, those coatings, those are perifluoral compounds. They are called permanent chemical products. That is, has never been happened. They are derived from PTFE, from Teflon, that make many of the paper packaging impermeable and several other products. From vegetal toxicity, that is performed by all certifying companies in a very similar way, where you're going to compare the growth of plants, interference of material in process of development of certain plants. But then it varies a little when we're talking about the soil, water, marine biodegradation. So there are several things that we have to take into account. Here, certification of home compostable. That is a home certification. We have to take into account that the thermophilic composting process reaches to temperatures between 55 to 75 degrees centigrade. That is very important, very interesting, because they provide, in the case of, you got to remember that most of those bioplastics are polyesters, so they help in a hydrolysis reaction that happens, which is a natural chemical reaction that happens when we have humidity and temperature. So thermophilic process, because of the microbiome, the activity of the microbiotic activity reaches that temperature. But the domestic temperature in our tropical country happen at temperatures between 30 to 40 degrees Celsius, which happens that there is a population of microorganisms that is much smaller. When the food ends, fungi and bacterial temperature drops to room temperature. That's why you know that the composting process ended when you converted all the organic matter into humus. And the CO2 that was released in the process, the same CO2 that the plant, when performing photosynthesis, receives. So we are producing in the carbon cycle. So in exception from the fossil carbon that was there stored, and we're bringing it here to the environment again. But this is a problem because same way in domestic composting, it involves vermins, it involves worms, microorganisms. So we have to be very careful when it comes to how we test it in domestic composting, because since it does not happen in all cities of Brazil, etc., it catches that potential. That it's a very attractive potential of several products that we consume that we could treat in domestic composting using as a community or in small spaces or small companies in districts, communities, etc. So the home compostable products have gained great deal of interest as long as they can meet this, the being capable of being biodegradable. The European Committee is working on a technical norm focused on plastic bags, on bags for certification of home compostable. There is a technical norm that is ongoing. It's going to be approved in a while. Uh, Basically, the requirements and chemical tests, carrying bags, well-managed home composting. That is where, how do you characterize that is a plastic bag, a shopping bag, a carry bag can also be worked that properly were in a domestic composting facility where we don't have the same control. That is the same condition as industrial composting that can monitor and ensure those conditions for degradation. So this norm brings some innovation, which in addition to having to pass on the other certification tests, etc., it'll be tested directly on some uh, standard Felix says it is going to have a 9% of mature compound, and then you're going to have on it starch, 2% of fresh vegetable, etc., etc., etc. Another composition with organic waste of rest of food, and that is going to be put in some boxes and have to watch if the small population of microorganisms, the small temperature below 30 degrees centigrade, if this is going to be biodegradable. So in a qualitative way, there is no how we can do this. We have standards that are being reproducible and safe. But, João, João, please, sorry to bother. You're exceeding the time a little. If you can speed it up, I'm sorry. I'm sorry, I apologize. Anyway, what I say is that something is domestic composting, other thing is increased vermicomposting because our material is not appropriate for this. But all is can be the chemical analysis of the material, the analysis of biodegradation, how it happens, the integration and biodegradation of composting, and ecotoxicity. So, my final remarks are that the compostable material, the material is compostable when it becomes a compound after biodegradation in biological media. The final compound can be used for regeneration, filtering of agricultural soil, recovery of degraded area. There is eternal demand for this resource. This process can be carried out in small, large, and mid scale process together with other compostable residue in general. At the end of the life cycle, compostable material no doubt has environmental impact mitigated and can be valued and have a big contribution for the generation of agricultural soil. But finally, according to our objectives, we need that technology of identification of the biological that effectively are effectively created and communicated in productive chain. We need the infrastructure of biological structure, even though emergent Brazil should be built, adapted, expanded to be able to recover effectively the compostable products. And also say that at Abicon, in Abicon, we recognize, we validate as an industry association the international scientific organizational standards used globally. That is, Abicon defends, promotes that products certified internationally shall have total validity in Brazil, because this is our system. Certifications prove those requirements they met, promote better communication of the attributes and the properties of the user in the whole product agent. Thank you very much. Sorry for exceeding the time.
No problem, John. Just a little bit. I believe it won't affect anything. Thank you for your presentation, very clarifying. And now we have the next presentation, Alex Ricardo Slach. He will talk about bioplastic, recyclable bioplastics with renewable source. He works focusing on the consumption goods and works for Braskem since 2012. In his previous position, he dealt with the international trade. He has very long experience with polymers in engineering of high performance. And He also works in GF Plastics. Alex is an engineer, a material engineer in São Carlos University. Alex, be welcome. Please take the floor. Thank you, Ellen. I would like to thank Lucia for the invitation. It's a pleasure being here. It's an honor for Braskem taking part in this event. I believe that the only problem is doing a presentation after 5 classes we had before me, but I'll try quickly focus on the theme, which are the biopolymers, recyclable biopolymers. And I would like to start this talk about how I went to Braskem, and over the 10 years I'm here, the last 10 years, and I recall the former office we had on the walls. We had the strategies and focus of Braskem between 2010 and 2020. Ambition being the biggest producers in the world of biopolymers. We started producing green fields. In this case, we call it Quer Verde. Then this project is 10-year-old, 12-year-old. It's very interesting. Several stages in Brazil, developing abroad as well. The most important point is the DNA, the interest of Braskem, not only on economy with renewable sources, but also in the second stage on the circular economy. It's not limited specifically to the polymers. So here I take the chance to place some macro targets of Braskem concerning sustainability. And the targets have always been part of the interest of Braskem and the history of Braskem. They will remain there forever. Braskem effectively believes that solutions of renewable sources are in the circular economy. 2 things have to happen together, pari passu. And the presentations we heard have approached the matter. I'll go further, carrying on with the solutions Braskem may offer in this backstage, circular economy and renewable sources. When you consider the slide, on the left side, you see solutions that have more renewable sources in the products we offer. On the right side, you see effectively the solutions linked to circular economy. So going to the mid of the slide, we see a material that's very interesting. Is the combination of the green PA with recyclable plastic. So polyethylene, PP, renewable source, has many characteristics that are very interesting. Totally recyclable in the chain of fossil resin. Going back to the slide, on the left side, the product that Braskem calls pé verde, it's polyethylene, high density, low density, and ABA produced via sugar cane. So going side by side with a family of products that's not commercialized yet by Braskem, but it's the use of renewable sources to produce polymers, chemicals, using for that a certification of origin. So it's a balance of mass balance. It's a renewable source as the base for the production of polymers and other chemicals. In this case, in Braskem, we focus on polypropylene. And as I said before, in the middle of the slide, you have the combination of polyethylene green with resin from the circular economy, i.e. recycled. So side by side with it, we have a circular economy originated from mass balance. So there is the collection, the gathering of waste, polymeric and solid, depolymerized and transformed into raw material, recycled and used by Braskem in our sites for production of chemicals. And it's advanced recycling, and there is a certification for that. Last but not least, the recycled resin in the circular economy, in the mechanic recycling. Braskem has launched a new plant with mechanic recycling, linking and doing this transformation of the circular economy. So what's a polyethylene that is originated from plants? What's a green polyethylene? I believe the slide shows it. Today, we've seen it several times. Polyethylene originated from renewable sources is basically a thermoplastic, can be recycled, but the source of the raw material, instead of using oil, we use other sources that are renewable. The source that Braskem has chosen for that was sugarcane. So we see how this process works. Anyway, polyethylene of renewable source is not biodegradable, and it does not have the petrochemical source linked to it. It's a recycled resin of a renewable source. This slide shows a little bit about the reason why the level of the level of impact that Braskem generates with this product. If you consider the total area of Brazil, we have more than 150 million hectares available. And in these over 850 hectares, practically 150 are native area. So we have the balance of 300 million hectares to be worked on. And then practically half of it are used for pasture of cattle. So 56.5 are available areas, 57 million for agriculture, and of the 77 for agriculture are used for sugarcane. So you see the volume of sugarcane used by Braskem to produce the polymers of renewable source. It's a consumption of 0.08% of all the area available for agriculture, 77.3. So we know that a good part of sugarcane that Brazil produces is used for fuel. The other part, as Professor Julio has commented, is used for sugar production, and there is a balance between the two. So sugar and ethanol. This ethanol is exactly what's the raw material for Braskem. So as you can see, And so you see the way polyethylene is produced with renewable source. How is the production of this polyethylene with from renewable source? Sugarcane is transformed by the producers, sugarcane plantation producers. They have their own usines, they have their own plants. They obtain the ethanol and the sugar from that. And Braskem starts the process there, buying the ethanol and doing dehydration, transforming it into ethylene, ethene. From onwards, everything follows the same stages of production of fossil source polyethylene. So obviously, with the possibility of existing a recycling in the end of this process. So this resign can be in the economy circulating without any problem. I brought this slide in order to do a comparison between the two ways of producing and polyethylene as an example. If you take on one side, so with the pointer to be easier. You see on the screen, huh? Sugarcane, green polyethylene, we start with sugarcane, and ethane is produced with a fossil base, or you use natural gas or petrol, and this petrol is refined, transformed into naphtha. There is a cracking. After the cracking, we have the purification, and it ends with the fossil ethylene. And you see the sugarcane side, you have the ethanol, the dehydration, that's where Braskem starts, purification of the ethane that has been generated, the ethane, and then we start using the production of the ethane. The plants that are used for pulverization are the same plants of the polymerization of polyethylene that is fossil. This is one of the characteristics that is very important in the green leaf. There are several polymers of renewable source that you have to do several adaptations in order to produce the end product. It does not happen with the PA Verde, because the characteristics of the fossil polyethylene, except the age of the carbon that we are using to produce the polyethylene, you can, in this PA Verde, you can use the same process. So it's common. So basically, there is no adaptation. I think just taking the opportunity, there is a question in the chat talking about LCA. This is a very important aspect in the PA Green. So people that are listening to us, please pay attention that LCA are tools that are alive. They change from time to time. There are living matters. There are new standards, of course. So, but this is the figure we have today. So comparing the footprint, the carbon footprint of PA Verde versus the polyethylene footprint. So polyethylene, the fossil one produced by Braskem, for instance, and the polyethylene produced in Europe with the energy matrix with a larger footprint than in Brazil. And so, in fact, there is a gain that's very relevant when you compare the carbon footprint concerning the PA green. So it's obvious that this analysis of life cycle concerning carbon footprint, etc., comparing to PA green, this figure will not be so attractive to any type of polymer that we have in the market. I believe that each case is a specific case to be studied, but the slide presents the comparison between the green PA versus the conventional polyethylene. So, as I explained before, practically, the only difference or biggest differences between the fossil polyethylene and the renewable one, they refer to the ethane. After the ethane production, the way that it's done is very similar between the two. We have a higher flexibility to produce these several families that you see on the screen, several of polyethylene, since low density to high density, linear, etc. So the most recent is what you see on the screen. They are available for applications, and then we can produce flexible applications, let us say food packing or rigid packing, flasks, cosmetics, and also rigid packing for food, etc., and others like bonnets, etc. Everything that you do with EVA and polyethylene can do with green polyethylene. So I will present here, you see safety helmet that is hard. And so before presenting the applications, there is another point that's very important. Braskem has started with the green polyethylene. There is a brand, I'm Green. It's Braskem's brand. And we present it to our clients in order they use it in case they are interested working with this brand. So it's like a seal. And so when you take a product, some cosmetics, for instance, with Brazilian trademarks, normally the Brazilian brands present the I'm Green label. So it gives strength to the product. And something else that's very important too, that I would like to present here with this image. It's very interesting to observe the green polyethylene because you have the measures of the amount of renewable sources that you have in your product. So there is a concerning carbon measure, it's 14. So you distinguish the fossil source from the green polyethylene. It's an analysis that's so simple to do, very quickly done. And this is another aspect that's very important to consider in the green polyethylene. Talking about some success cases, I cannot go very long. I've just taken some. The first one is actually the water bottle in Holland, reusable bottle. It's produced with green polyethylene. It used to be fossil. Now it's green. This company promotes, in fact, the increase of the consumption of potable water, and it's focused on developing countries to improve the use. Another case I brought is concerning artificial grass that have been used in Tokyo Olympic Games, in hockey fields, hockey courts. So it shows the flexibility of the product. So it's a rigid packing in the bottle, water bottle, and now this one, which is flexible application with artificial grass. Last but not least, obviously, if you're interested, After the presentation, I have my contact, so you can send any question. Feel free to contact me. This part concerning soles, shoe soles. So several companies obviously very much interested in concerning this carbon footprint aspect, working with low carbon footprint, with applications in the disposable soles of shoes. Talking about investment, end of this year, Braskem will start the expansion of Rio Grande do Sul's factory. We have one plant that is green polyethylene that's active. It started in September 2010, and Braskem is working this year with the expansion of this plant. Practically, we'll have $300 million invested to increase the capacity to 60,000 tons. So it's also to show the interest of Braskem in maintaining its position in leadership, biggest producers or a big producers of polyethylene, green polyethylene. It's not the only project that we have for renewable chemics. Besides the polyethylene, we have other products, not necessarily polymeric, but they are chemic, that Braskem is already considering to work with renewable source. For instance, the Meg Verde, it's an investment with Braskem that started in Denmark, which is the Meg Green. There are other products that are different in this Meg Green chain. And in the long run or medium run, we'll have a lot of things that will be very interesting with renewable sources and looking for a transformation. The chemistry will be more and more renewable with time. These are the contacts. I tried to speed up to go back in time and present all that is necessary. So I pass the floor back to you. And I thank again Ellen and Lucia Fernando and Lucia, sorry. I thank you all. Thank you, all the speakers of this morning. And now Verusca, the moderator, will be managing the presentation of the questions in the chat in YouTube. Okay, we'll share with all of you the speakers, the screen, or we call each one as the occasion rises. What do you prefer? May I suggest that all of them stay here with us. If you do not have any other recommendation, I would like all the speakers to stay with us now. So first of all, thank you all the speakers. The presentations were fabulous. Many questions in our chat. We will try as much as possible to link the questions so we cover all the doubts. I will start with Julio. There is a question that's very technical concerning the PGLA. The only one that's considered biodegradable in the sea is PGLL. I learned that in off-start course. And so anybody's expert in the subject? I don't know. Among the speakers, who can answer? I'm curious about it. Who wants to answer the question? So this is a pending question. We'll research later on to give the right answer. Now, a question to... Okay, Ken, regarding PLA, Rodriguez asks, my biggest question is that they are compostable in commercial activities, not domestics, and take months to do the decomposing on the earth or on the seas. This is an issue that is discussed. The PLA is compostable in the usines, in the plants, so we educate people to do the right disposal of this material, but the fact is a movement that is increasing abroad. We see that is stronger in Europe, in the United States, in composting plants, together with the municipality and the government. They are doing more and more actions in this sense. And so, as in the ERT, we believe that we have to give incentive to have more and more materials in this chain as a whole. So concerning the collection, the composting, and the way you give incentive to the use using more and more materials, and that will go to the economy. All the materials we have that have to be in circulation, they have to have the right certification via one way or another. It's extremely important. So the correct materials have to go to the composting sites. May I complement or not? Okay, we have to respect the standards concerning thickness, for instance. You have to observe it. Okay, so the composting way will depend on it. Of course, the part has to be observed. And so it has to be submitted to tests of a certifying agency. Okay, people say, just put it there. No, no, it's not this way. It has to be certified. It has to be clear in our minds. Thank you. A question to Leonardo regarding how would I say, recycling of the bioplastic. It can be recycled together with conventional plastic. How does it work, the bioplastic recycling? Excellent question. It's a doubt in the market normally. Bioplastics, thermoplastics as the others, they can be recycled mechanically, yes. And the rule is, the rule of the market, each polymer has to be recycled separately. You cannot use the PET with PVC because it contamines. So high polyethylene and low polyethylene together, yes, but between the other materials, you have to do it separately. Each material has to be recycled separately. That's why we have the collection centers and selection of the materials in order the work is used accordingly, as it has been presented today here. Thank you, Leonardo. Alex, taking the chance concerning recycling, the green polyethylene, has it to be separated in recycling, or it's a polyethylene, so it can be together with the other conventional polyethylene? The green one can be recycled together with the others, the traditional ones, no problem, no harm to the characteristics. It's, as I presented, production is different to the ethane phase. Onwards, it's just like the other polyethylene. Of course, Braskem uses the same plants, so the characteristics of the resin are there, extremely similar. So we cannot say identical, but they're extremely similar. So in some cases, they are identical. No problem. So, Alex, a question which is interesting concerning the base. So, bagasse originated from sugarcane. So there is difficulty, economic difficulty, because the price depends what is variable in terms of production, what's for alcohol, what's for sugars. Is it a risk when you consider the price, so to be with a very high price? It's a very important question. If you compare the price of the fossil to the green material, we have to consider, no doubt, that the cost of green polyethylene is different from the fossil. The fossil has the naphtha and the petrol to be considered. On the other hand, the green one is ethanol. Most of the cases, no, some cases, it follows the same trend, but if you consider historically, they do not follow the same procedures. There is the risk. Sometimes the price of the green polyethylene goes to one direction and the petrochemical goes to another direction. There is difference in the prices. Unfortunately, nowadays, with the raw materials in this range, petrol is close to $100. Ethanol, as it is, it's more expensive to produce the PE green than the other one. But they change along the time. You cannot say how much, but it's different. When you consider risks, cost risks due to ethanol, I do not see it as a risk. Why? Because the volume of ethanol that's used and sugar cane that's used by Braskem to do the green polyethylene, unfortunately, it's small. Why do I say unfortunately? Because we are not distributors of fuel. So what we buy, there's no meaning, significance in terms of price. So we would have to produce much, much more to consider that we are generating an impact, economically speaking, in the price of ethanol in Brazil. So I don't see it as a risk. I see it, the production of sugarcane, ethanol in the chain, taking sugar together. It's something that will be maintained for a long time in Brazil. And I see that, according to Professor Júlio's opinion, in some moments, we have to combat the use of sugar as food. Maybe it will be healthier to have less sugar. Okay, so we produce less sugar and we use sugar for other purposes, leaving a space for ethanol and for the production of chemicals and polymers. Okay, thank you. A question to Philip, please. Okay, I'll carry on in Portuguese. Would you say that the standards and definitions in Europe related to bioplastics are understood well by the end users in Europe? Because in Brazil, there is confusion about the understanding. I would like to know the end user in Europe. Do they understand it all right?
Yeah, I think that honestly the confusion is the same on this side as well.
Confusão lá e aqui.
If I ask my wife or my sister what is the difference between biodegradable and bio-based, and nevertheless I speak about bioplastics every day, there is still confusion, and that's the reason why education is probably the only way to better explain and to better understand the difference between bio-based and biodegradable. And that's the reason as well as marking must be different. You cannot cover with only one sign, with one logo, the fact that the product is safe, that the product is sustainable, that the product is bio-based, biodegradable, ethical, not using kits, and etc., etc. So that's the reason sometimes I heard that there is too much logo on the market, but if you have only one logo, you cannot make, you cannot understand what is behind the logos.
Obrigada. Uma pergunta para o João, por favor. Uma pergunta
Thank you. A question to João. A question that appears practically in all seminars, but it's important to clarify that. Do bioplastics leave residue in the environment? Perfect. Well, the question is quite generic, environment. When we talk about environment, we have to define which environment. Well, the fact is that materials that have those qualities of being biodegradable or compostable, they are biodegradable in certain environments. That is, if a PLA, for example, because PLA is a very interesting example. It's polyester, but there are PLAs which are compostable, and it's a family of products, just as PP, there are hundreds, PE, PET, whatever, and there are PETs which are not biodegradable, depending on the chemical structure they have. Theoretically, in this era of circular economy, we have to move it to process of recovery and valorization after consumption, either in recyclable chain or compostable chain. I think Philip, in his presentation, left a message at the end saying that biodegradation is not a license for anything. It is not an attribute. Being biodegradable is not something that just because of that you can throw it away. So anything that goes to the wrong environment can cause problems. The fact of the matter is that since bioplastics are products that have a chemical structure that naturally make them biodegradable without the addition of additives, without fragmenting agents of degradation, the chances are a lot smaller. But when we look into the composting processes, I said in real life of the composting industry, we have to be very careful because it may end up having some residue, even though the biodegradable, if the process is not well done, we may end up having some kind of fragments. And so this is what we have to be careful with. When in the technical norms, we refer to the fact that 120 days, 90% of biodegradation, and you may have 10% with a 2-millimeter siege. This happens because it's an extrapolation over time. But if 9% is 120 days, the other 10 will. So we got to remember that the conditions in the industrial composing process are much better than the ones that we have in the lab. So they have a chance of being a problem, just like as any other material, any other product that is incorrectly discarded in the environment. But they gain a lot because the fact that the biological process can convert them fully without leaving toxic residue. Thank you, João. A question to Leonardo, please, regarding the terms of biodegradable or not. Let's say that the conventional plastic is biodegradable, even if over a century, or is it wrong to say, and we cannot say that the plastics are conventional biodegradable, even taking this long to become biodegradable? It's wrong. As in Philip's presentation, he's shown the different types of degradation, in biological, environmental, or post-degradation, degradation by light, by oxygen, etc. So we cannot say that those conventional plastics will be degraded by biological mechanisms in a certain time.
Obrigada, Leonardo.
Thank you, Leonardo.
Fernanda, ela tá
Just a remark, if you allow me. Everything is biodegradable in the world from a scale of time. That's why we created a norm to say 180 days. May be biodegradable. Do not confuse the term that the lay people in the other side here. Everything in the world is biodegradable.
Imagina, aproveitando, Júlio,
Okay.
a gente tem aqui a pergunta da Fernanda
And
para você.
making use of questions from Fernanda to you, is there any harm in the ecosystem of those bioplastics coming from phosphorus sources? Didn't understand the question.
Eu confesso que não entendi tão bem.
And I did not understand it very well.
E ela quiser esclarecer.
If we want to clarify in the
A
chat,
gente complementa.
if not going to respond incorrectly, it's wrong.
Não, então tá bom. Então vamos lá.
Okay, let's move on.
Aqui, ela não veio adressada a ninguém específico, mas
It's not for anyone specific, but what can help us in the response is the commercialization of those bioplastics in Brazil. Which companies are doing this here? And here we already commercialize it. We have a distributor that does the distribution of our materials here. And our objective is to make more material available to the Brazilian market. I think the Brazilian market suffer the lack of material at very high prices. And over time, our objectives is to invest in our plant here in Curitiba. We are investing in increasing capacity, increasing technology, verticalizing, so that we can make more materials available to the Brazilian market. As in our presentation, the Brazilian market, we desire this, the Brazilian market desires this kind of solution. And the PLA, together with other bioplastics, they have important qualities. I think that the materials, some bioplastics that we see, which are the future of the plastics. But I believe that PLA, we have important functions, like scalability. This is fundamental for the industry to convert as a whole. Scalability is important. Applicability, the PLAs and the PLAs plans, they have a range of application that are superior to the plastics being developed, and there is price. I think at the end of the day, price is an important, extremely important factor. Everyone knows we're not going to convert the use if you don't have a price. And we're going to deliver this. We believe in sales of PLA, sales that can deliver this kind of these three main attributes. So we can say that there will be no lack of sales of PLA in Brazilian market if it depends on ERT. Okay, thank you. A question to João. Actually, it's more of a comment that came because Abicola recognized the systems of international certifiers and their labs. Once Philip is here talking about the system used by TUV, is there a possibility of any partnership with Abicom so that we can further develop the certification process here in Brazil?
I had a look on the website of Abicom during the presentation. Let's talk after.
João, você poderia só posicionar?
Well, sorry, I understood that the question because I caught the eye for this, but it was a good question for Philip. He even wanted to compliment us a little, but anyway, no doubt we need to build those bridges. We don't need to reinvent the wheel here in Brazil. We don't have it. There is a lot of knowledge, lots of know-how. That's not only the norm, what is described, the methodology, and type of the breeder, etc. We have the know-how for the results. There are thousands and thousands of tests of certified products that uh, are in the global market. So Abico has a lot of things because of our similarity of our technical norm with the EN. So we would like to build this partnership with TUV to expand the possibilities of local certification in view of the fact that we have a barrier, which is the non-existence of laboratories to do that in scale. The universities have the capacity of doing it, but they can do 1, 2 tests per year, tops, all done on the bench. So if we want to expedite the introduction of reliable products in the market, if we want to banish the greenwashing that we have here, because we are infested with false allegations that are causing problems for the composting industry. That's why ABCOM, understanding the scope and, and of the false products. So here we have the invitation to talk later, Philip, so that we can somehow draw a more objective and promising interaction for the companies. Certainly, a question from Aline regarding the composting plants. Do we have composting industry at a recognized level here in Brazil? Indicate where they are located. How is this process going? Could you tell us how this is going? We have a sector for composting that is emerging in Brazil, but quite incipient. So the United States, they have 4,733 composting companies. The latest data that I got from the US composting, uh, if you look at the European network of composter, you're gonna have there thousands of composting companies. In Brazil, we have some hundreds. But due to the fact that this is an emerging demand in a situation in Brazil that 50% of what we call garbage is composted human waste, it's a matter of time and change of culture. The agricultures were all used to an activity based on chemical manner. So minerals and organic have gained the space. Let's say that we have some 10, 30, 40 big companies that do composting more than 1,000 tons a day. And we have something that 200 for small companies that those are low scale companies that work like 100 kilos to 5 tons per day. But what I can see is that it is an irreversible demand from society. We can no longer send organic waste to landfills. We have a legislation about that, to dig holes and bury it is just increasing problems because all uh, everything that you bury doesn't cause CO2, it causes CO4, CH4, which is methane. And probably landfills are the second greatest source of emissions of that gas that happily COP defined the goal, radical goals to eradicate with. So it is a matter of time. There are no technological barriers, investment is not too high, and we can see a situation of composting park around Brazil to eliminate mainly the food waste, because we have food waste. 50% of what we call waste is composable material. Okay, I think that we could close with this last doubt. I do not know who would have the answer for this, because a specific niche regarding the hospital waste, packaging of hospital waste, discarding of it. If there is any process or anyone has any project, because you know that that's dangerous waste. So bioplastic could contribute somehow with this kind of waste. Would anyone have any comments about this topic?
See, in our case, maybe we have some product used in hospital which are certified, okay, bio-based. But of course, as you said, these are quite dangerous waste and are usually incinerated. And so it's a nonsense to make them compostable. But bio-based makes sense because you incinerate, so we reduce the amount of new or of old carbon emission when incinerating bio-based products.
Ótimo. Felipe, você teria alguma consideração
Felipe,
para ajudarmos no encerramento aqui das dúvidas e esclarecimentos?
I know the translation.
Felipe,
so
would you have any doubts or any clarification to help us in the final part of the clarification? We are closing the doubts, and I would like to know if you would have any further clarification to contribute with the closure of our morning panel.
I think that, as I said, education is very, very, very important, and such an event as yours today participate to the education of the different stakeholders. And of course, I am in that business for more than 20 years, and I discover new things and new issues daily. There is room for improvement, but I am strongly believe that education is probably the most important, because we can develop new standards, we can develop new products, bio-based, compostable, and so far. And at the end, if at the end the consumer doesn't make or doesn't dispose that product correctly, it's a nonsense and wasting time and energy. So education first.
Educação sempre.
Always education, certainly. Would anyone else like to close with any final remark? I leave it open to you, all of you. Just corroborating with Philip's words, education is the base for everything. So we have to pay attention to this. Just strengthening a phrase here that on earth, nothing is created, everything is transformed. If we educate correctly, we do the proper transformation. Thank you. Anyone else? I think that just to complement, to congratulate your work at Beacon, you play a very important role in this education. I think that João and you, together with your team, I had the pleasure of working a little with you, and I'd say that that's the way you work. It is not our main work there. It's not your core job. You do it with solidarity, but aiming at precisely this: disseminate education, disseminate correct information, create standardized processes, test methods, so that you can stimulate this industry, which no doubt is not the future, but rather the present. Certainly, I agree with Kim. It is fundamental that we disseminate the proper knowledge about bioplastics and all the possibilities that they can bring. It's important that the final consumer should know that there are those possibilities, and they demand from the manufacturers of plastic artifacts and the governance that those solutions should be really implemented, and that this cycle should be closed from the cradle to cradle, from the beginning of the chain to the end of the chain, returning as the raw material. Alex, would you like to contribute? I would just like to thank you. I think it was very interesting this morning part, and to make use of the opportunity to invite everyone to continue and watch the afternoon part for Yuri's presentation about packaging forward sustainability. So starting at 3:30. But thank you, and I'm available to you to any doubt. Thank you very much once again. João, just to thank once again the organization, because without this kind of event, we cannot cooperate, we cannot have a joint effort. The construction of our mission is gigantic in Brazil, so that we can bring this characteristic of sustainability that's so greatly desired for society today. I think, no doubt, and I'm available to continue with our questions that weren't answered. We can answer them later. And as a beacon, we're available. And without you can contact us through the social media for doubts and everything else. Thank you all. Ellen, I think I gave you the floor now, huh?
Exatamente.
Precisely.
Muito bem, nós vamos
Okay,
encerrar.
well, we're going to close here.
Vamos encerrando aqui essa sessão de
We're
perguntas.
closing this
Por enquanto,
Q&A session.
não é
Because
possível
of
responder
time limitation, we cannot answer all those questions
que não foram
that were
respondidas.
presented. Those that were not answered
Os palestrantes.
will be sent to the lecturers
Agradecemos muito a
later.
participação da Verusca, nossa
We
moderação.
thank the participation of Verusca.
Essa manhã,
That was the moderator of panel number one. Thank you, Kim,
ao João Carlos,
Bernardo, João Carlos, Alex, Felipe, for your excellent presentations. We remind you that after the third panel,
que é o terceiro painel é à tarde, estará
the third
disponível
panel in the
no
afternoon,
chat
a link will be available in the chat box with a form for registration and assessment for the emission of certificates. All participants that fill out the form will be given a certificate by the registered email, and they may also ask the sending of the presentation from the participants. Your assessment and your comments are important for us to improve the contents. We're going to have a break now, and we'll be back here at 2 o'clock. During this break, we're going to reproduce the video of some of our sponsors, Brascan, Bioplastics, BRT, and Rapid. Thank you, and see you later.
gente não consegue acelerar o tempo. Mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
creating tomorrow's solutions.
consegue acelerar o tempo, mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
creating tomorrow's solutions.
gente não consegue acelerar o tempo. Mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
creating tomorrow's solutions.
A gente não consegue acelerar o tempo, mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
Creating tomorrow's solutions.
A gente não consegue acelerar o tempo, mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
Creating tomorrow's solutions.
A gente não consegue acelerar o tempo, mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
Creating tomorrow's solutions.
Boa tarde a todos. Vamos lá.
Good afternoon, everybody. Let's continue with Bioplastics Brazil, thanking the contribution of our sponsors, Activas Brazil Additiva, Bioelements, Bruskin, ERT, Earth Renewable Technologies, Futamura, Pyramidal, Telpal Proctec, and Vacar. We also thank the lecturers, moderators, and all participants who's gonna follow us in the second part. This event has the technical institutional support of the Brazilian Association of Biopolymers and the media participation of Media Industrial. We continue with the panel 2, application of process and improvement of properties of polymers. Now I give the moderator, Claudio Aparecido Marcondes from Plastic Experience. Lecturers, Ingo Jeschke from Wacker and Sidney Nasser from Therpol. Now I'll give the floor to Claudio Marcondes. But before, I'll speak about Claudio's history, today's moderator. Claudio is a master in engineering of materials by Unicamp, engineer of materials, polymers by the Federal University of São Carlos, graduated in financial administration by FAAP, with a graduate course by marketing administration by ESPN, graduated in management of innovation by Unicamp, has experience of over 30 years in the areas of development of products and markets. He's worked in Pirelli Cabos, Poly Brazil, Polydist, No Nox, Ceatex, Vidotel, Chromex, Arbus, and Thermoplan. Today, he is professor of the Institute of Packaging and technical consultant of several companies in addition to working in the press experience platform. All right, Claudio? Yeah, sort of this. Now it's up to you. It's a lot of publicity, but we're here some 30 years in the market and always to the area of development of products in the markets. My biggest experience was polypropylene, which most of you should know, which is this man here, Julio Lata, behind me. There was an anniversary of 50 years, which happened in Basel. So I'm making some publicity for him. Thank you. Okay, Claudia, up to you. You're going to be the moderator for our presentation in the afternoon. And I'm going to introduce to you our first lecturer, Dr. Ingo Jeschke. He's from Wacker, the Wacker company. Dr. Ingo Jeschke studied chemistry at Munich University, where he took his doctorate. In Clarence BMJ, he commercialized antifreeze fluids for aircrafts for 8 years, which was the beginning of a large career in the formulation of products. After 2 years at Clarence headquarters in Switzerland, he joined Heimscam GmbH and his new business group that was founded, where he developed modern applications in air nutrition, solar, and agrochemical. 3 years later, Dr. Jeschke joined the Biosolutions division of Wacker Chemic AG, developing new applications of cyclodextrin in agrochemical and industrial sectors during a decade. Since the beginning of 2022, he became the manager of development of business in the division of polymers at Wacker, and responsible for improvement of efficacy and performance of biopolymers with the use of Binex additives. Please, welcome. You may start your presentation.
So I guess you can hear me now. Yeah, thank you very much for your nice words and also for the opportunity to tell you a little bit about the Vinex product range of Wacker Chemie. As you have already heard, I'm based in Germany. So from my side, good evening, because it's already 7 o'clock here, whereas you just had lunch. And I would like to take this chance to explain to you a little bit about the Vinex product range of Wacker Chemie, which is a product range which can in general be used in order to improve the work with all different sorts of polymers, and also which can be used in order to improve the physical properties of different polymers. Before I will start with the with the technical part, I would like to introduce to you a little bit of Wacker Chemie, so that you have a better picture of the company. Let me see. Okay, here. So Wacker Chemie is a German company which was founded a little bit more than 100 years ago by Dr. Alexander Wacker. So this is the guy who gave the name to the company. The headquarters is in Munich, but the main production site is in Burghausen, which is about 1 hour's drive east of Munich, right at the border to Austria. And as you can see, these are the latest figures of the Wacker Group in 2021. So you get it's roughly 6.2 billion euro sales. You see the EBIT, the numbers. You can read them by yourselves. But you see also that we have roughly 14,000 employees on a global basis. This image just shows you a little bit how the company looked like in the past. So 100 years ago, the reason why this company was founded there was based on the electricity which we were able to get from the water from the channel. And in the black-white pictures, you see the old structure, whereas on the left, on the bottom, you see how the company looks today. So 10,000 people are working only in this site, and the city of Burghausen has only 14,000 inhabitants. So basically every second person of this city is working at Wacker Chemie, so to say. The products which Wacker Chemie is selling, is producing and selling and distributing on a global basis is basically going into all different sorts of industries. So here you have a small part. There are a lot of products going into automotive, transport, construction, energy, coating, paints. This is a little bit where we come into touch with the polymers and adhesives and sealants, consumer care, elastomers, plastics, and so on and so on. So basically, Wacker is an expert in many different fields. There are actually 4 different divisions, the biggest being the silicones division. The second one is the polymer division, and this is the division I'm currently in, and which is also basically the division responsible for the Vinex products. Then there is the polysilicon and the Wacker Biosolutions division. A lot of the materials which we produce are based on 5 basic raw materials, and I will not go into details. This is just in order to show you that how the product range is being built based on methanol, silicon metal, and then based on ethylene and acetic acid. The vinyl acetate monomer is being produced, which is the basis also for the Vinex products and for all different sorts of other polymers. And then finally, also there is starch dextrose, which is the basis for fermentation plants for the biosolutions part. Also here you see the presence, the production sites and the technical centers. So you will also find that very close to Sao Paulo, we have our office in Brazil, where a technical center can support you and also where parts of our products are being produced. But now let's come to the technical part. So Vinex, actually there are 3 different types of Vinex product groups. There are the Vinex powders, which are copolymers of vinyl acetate with ethylene. There are the Vinex resins, which are either homopolymers of vinyl acetate or copolymers of vinyl acetate with vinyl laurate. And there are also the Vinex LA blends, which are basically mixtures of certain Vinex resins with polylactic acid. All of these products can be used in order to improve the processing during the work with bioplastics, and also to improve the physical properties of bioplastics. And they can also be used in order to improve the compatibility of different polymers with each other. As you can see here on the left side, Vinex can be used with all different sorts of polymers. The typical use concentration would be in a range between 5 and 20%. And on the right side, you see also the individual products. So you have 4 different powders, 7 resins, and 3 LA blends. We will get into more detail a little bit later. But beforehand, I wanted to let you know that the particle size of the product is very much different. So the powders are very small. They have a particle size of just a couple of 100 microns, whereas the resins and the LA blends have particle sizes between 1 to 5 millimeters. And this basically also makes a big effect on what product you can really work with in your equipment. To start with the powders. As I have already said, the powders are copolymers of vinyl acetate with ethylene, and they can be regarded as soft polymers. And the last digit gives you some indication about the hardness or the softness of the product, with the 2501 being the hardest and the 2505 being the softest of these product ranges. The powders can be used in order to improve the flexibility and also the impact resistance of certain polymers, and they can also be used in order to improve the compatibility of different polymers if you would like to mix some of them together. Whenever you work with the powders, you have to go through a compounding step first, and then the compound can be turned by your production method into the final product. Let me give you some examples. So we have heard today already about PLA. PLA is a very famous biopolymer, which is used very much, but which has, let's say, a little disadvantage because it's pretty hard and brittle. So if you want to work with PLA, or if you want to turn it into products, you have to improve the softness of the product. And for this, you can work with the powders. And one physical property which gives you an indication about the softness of the polymer is the impact strength. So in this and in other slides, we mainly use the Ingeo PLA, but this works, of course, with every different sort of PLA brand. So you can see that the impact strength of pure PLA is pretty low. Once you start to add the Vinex powders 2504 and 2505 into the PLA, you can see that with an increasing concentration of the powder, the impact strength is improving very much, especially with the 2505. A scientific reason for this behavior is that the powder forms some sort of flexibility center within the compound, which still exists after the compounding step. And by this flexibility center, in general, the polymer is just gaining in flexibility and ductility. Another, let's say, effect which could be a little disadvantageous of some of the polymers and also in terms of the PLA is the fact that the crystallization step can take some time. And this is not very advantageous. This is nothing you really would like to see, because this means that the physical properties of the product can change over time. And so it could really destroy your product, basically. And in this specific case, we were working with a mixture of PLA with PBS and some filler, and then we added the Vinex 2504, which is a powder. and we were measuring the tensile strength and the elongation just as two, let's say, random physical properties. We were measuring them right after the production and then after 4 and after 8 weeks in order to identify if they keep within the same range. And as you can see in the slide, this is the case. So this is a very good indication that the crystallization process has already mainly been ended once the compound was worked with together with the Vinix powder 2504. And the reason for that is that on the surface of the powders, or the surface itself, can act like some center which improves the crystallization process, so that this process is happening pretty fast. On the right side of the slide, you can see some other benefits. So in general, the powders are very good for an improvement of the processing, especially also for the thermoforming. They improve the compatibility of polymers with polar fillers, but also the compatibility with each other. So the PLA is sometimes mixed with PBS in order to improve the heat stability. If you do this with the powders, you can improve that they blend nicely together. And also they improve the heat resistance, which is very important for hot fill applications. And this can be measured with an increased heat diffection temperature. Another point which is important for PLA is the seal bond strength. So a lot of people want to work with PLA on PLA, but also PLA on paper. And then also sometimes the PLA is blended with PBAT, which also improves the ductileness or the softness of the PLA. And what you would like to see, of course, is that those layers, they stick together pretty hard and they don't separate very easily. And this you can measure with the seal bond strength. So on the left side, you see a comparison of pure PLA on PLA. And then we were adding different resins, but also different powders. And as you can see, especially by adding the powders, the seal bond strength was increasing very much, which was very positive and very good. Coming to the resins, as already said, the resins are either homopolymers of vinyl acetate, which is the 25 series, and which has different molecular masses, with the 2522 being the one with the lowest and the 2526 being the one with the highest molecular mass. And the 88 series is a copolymer of vinyl acetate with vinyl laurate. And this is especially also a soft polymer. As you can see, what you can do with the resins, you can improve the processing. In general, you can improve the softening of your polymers, and you can also reduce the viscosity of the polymer blends. If you want to work with the resins, you have to go once again through a compounding step first, and then you can take the compound and turn it into your final product. It has to be mentioned, though, that with the resins, they don't have a very high, or let's say they have a very low melting temperature, and for that reason, they need to be transported and stored at pretty low temperatures. So especially for the 88 series, this temperature has to be below 10 degrees Celsius, which can be, let's say, a little bit problematic if we look at countries like Brazil, where you never see outside temperatures below 10 degrees Celsius. And for this reason, we have developed the LA blends, which basically are mixtures of 60% of PLA with 40% of various resins. So the benefit is that they can be stored and transported at just normal temperatures. And additionally, they can also be worked with by a dry mix. So they don't necessarily need to go through a compounding step first. So some people which don't have the right equipment, they really prefer this product because they can just take this blend and mix it with their polymers, and then they can just process the final product. But of course, you can also go through a compounding step if you really would like to. Let's have a look at resins in combination with PLA. It is what we can say is that the resins have a very high compatibility with the PLA, which can be seen especially at this DSC because there is only one glass transition temperature visible. If you mix 40% of the Vinex 2525 as a resin with 60% of PLA, the glass transition temperature is lowered by approximately 5 degrees Celsius. As you can see at the slides, the blends are very nice, very colorless, and highly transparent. So the resins, especially the 25 series, is a very good fit to work with PLA if you want to work on these foils. Sometimes, or some people, they work with PLA with the blown film extrusion process. And with this process, it's very important that the melt stability is high, is very good. So I have two slides I tried, or I have two videos. I tried to open them in a second. And what you can see on the left side, it's pure PLA. And you should be seeing that the bubble is shaking very much, which is a sign that it's not very stable. On the right side, it doesn't shake because the PLA is combined with the Vinex resin 2525. So the advantage is the process is much more safe. It's also, it can be going much faster. So let me see if I can, if I'm able to open these two videos. Okay. Next thing. Another processing method which is used very often is the cast extrusion process. And with this process, you don't really like to see the so-called necking effect, which means you see it on the left picture. If the polymer blend is like this, this is not very good for the process. But on the right side, you see that the PLA in combination with 10 parts of the Vinex 2525 basically doesn't have any more necking effect. And this is based on the fact that the melt strength can be very much improved by combining PLA with the resins. This is important for the extrusion process to produce coated paper and in general packaging films. On this slide, you also see that the melt strength of the PLA is pretty low. These are the two low lines. And if you start to add the resins by 2, 5, and 8%, you can almost triple the melt strength. So this is, once again, a very good effect. Coming to another very important production method for PLA, which is the injection molding process. This is a production method where you want to see a reduced melt viscosity, because if the melt viscosity is reduced, you have higher cycle times, so you can produce more pieces in a certain time, and you can also produce more, let's say, sophisticated pieces with very fine areas. And you see here on the left side, this is the high shear melt viscosity of pure PLA at 170 and 190 degrees Celsius. And then we added the resins, and then you can see that the melt viscosity was decreased by almost 3 times. The same effect is important also for 3D printing, other extrusion applications. And here on the right side, you see the low shear melt viscosity in this case of pure PLA and then PLA with the Vinex resin 8880. This slide is just a summary once again of the benefits which you can have by choosing the appropriate Vinex product. So choosing the powder or a certain resin or even an LA blend. Once again, on the right side, you see that this works with a lot of different polymers. And on the left side, let me just repeat the most important features. So you have an improved compatibility of your polymer with fillers or with other polymers like starch and even other polyesters. You have an improved processability. You can use also your conventional equipment, of course. You have an increased melt strength, improved impact strength, enhanced flexibility, an improved film sealing performance. You can reduce the melt viscosity. You can increase the post-crystallization process and or in general optimize the crystallinity of your product. Coming almost to the end of my presentation, this slide gives you an overview about the food contact regulations. As you can see, all powders, with one exception, have an FDA food approval. For the European Union regulations, it's a little bit more strict. So the same powder, the 2505, and also the 88 series of the resins do lack the EU approval, but the rest of them has the approval. So the rest of the Vinex products can be used for all food packaging materials, just to name you one possibility. And then finally, let me discuss a little bit the biodegradability. So we were running several tests where we worked with, in that case, with a mixture of PLA with TPS, thermoplastic starch. So the same amount of TPS and PLA was mixed, and then it was mixed, or the Vinex was added. And this blend was investigated under industrial composting conditions, and the 90% biodegradability criterion in that case was reached already in 65 days. We did another test where we worked with PLA only. So you know that PLA has, let's say, not the same biodegradation as thermoplastic starch. It takes a little bit longer. So if you work with pure PLA and then add some Vinex, and if you do the tests under the same conditions as before, which were the industrial composting conditions, the 90% biodegradability criterion in that case was reached in 160 days. So it took a little bit longer in that case. For the previous test, there is already a certificate available, which you see on the left side. For the second test on the right side, the certificate is currently at work. So in that case, DINSIATCO is the certificate institution. And you can see also on the right side, you can have an overview about the conditions. So if you take the Vinex additives, the powders 01, 2501, 02, and 04, you can mix them up to 20% with an equal weight mixture of TPS and PLA. And if you work with pure PLA, you can work with the resins 25, 22, 23, 25, 26, and with the powder 2505, also up to 20%. But if you use the 88 series and the powders 2501, 02, and 04 with pure PLA, you have to be below 15% in order to fulfill this biodegradation criterion. This was the last of my slides. So I would like to thank you for your time, your attention, and I would like to give back to the moderator, please.
Thank you very much, Mr. Yeshke, and we will carry on now with the presentation of Sydney Nasser of Terpol. The theme is biomodifier based on natural rubber of rubber tree and the plastic circularity. Sydney is a chemist and he is also, just a moment, also administrator, CEO of Terpol, and he is in the area for 40 years. He started in the lab of Protec as a trainee, and since 2008, he is the CEO of the company. So natural rubber in this focus is a modifier for several types of plastics. So Terpol technology is spread to several continents. Welcome. Take the floor, please. Good afternoon, everyone. Thank you for the invitation. First of all, thank you for inviting me. And Lucia, thank you for the effort in producing very good events. Terpol is a brand of a technology, and we will talk about it. And talking about the rubber plant, the rubber tree, and it's important in the plastic circle, the pillars, sustainable innovation, circular economy, reducing the carbon footprint, setting value in the brand. And so we foresee that two worldwide processes have a content of ESG, which is a very well-known brand. And also we focus on productivity. Terpol started with the necessity to promote sustainability via recycling and reverse logistics of products in plastic and rubber. And it brings very good opportunities and new opportunities to the circular economy. Why is it sustainable? It's an innovation based on natural rubbers. It's really a renewable source. So if you consider seringueira in Portuguese, Brasiliensis, so it is a Brazilian tree, a rubber tree, and it produces during 35 years, year after year, depending on rainwater only. So, and the forest, it's done, the work is done manually to extract the rubber. So a person that is expert to do this work gets 8,000 to 10,000 rios per month. So it's good for them. It's a good salary. So the persons stay there. They do not leave the places to look for other jobs. So it has a social role as well. And as we said, it produces for 35 years. And the trees have 5 to 6 kilos of dry rubber per year. So absorption is 150 kilos of carbon annually. And it is very positive. What did we do? We developed this disruptive technology because everybody sees the marketing and the green work of the company. We went directly to the tree. So our plant is there. This is our biggest differentiation in our development. So we use the latex of the tree. We added to rubbers, and we also see the possibility of modifying the blend. We modify the plastic. We start new products. We improve the flexibility of the plastic. We have recycling done in an easier way. And in terms of sanitation, it's zero harm. So we value the brands. This is the sole one all over the world. Let us say we are ahead of the United States. We have brands in Brazil, USA, is the Eurozone, China, Japan, South Korea, Taiwan, India, and Colombia. So it's a possibility of producing artifacts with rubbers using the process of injection, using natural rubber as the main raw material. So after vulcanized, we use it in many things and it is recycled. And the focus of our presentation is the modification of plastic using natural rubber as the media for the modification. As we said, we look for the possibility of using the circular model as much as possible because it means less energy, less CO2 emissions, less pollution, more jobs, more raw material, bio raw material. In the case of rubbers, we serve the footwear, the auto parts, artifacts in general, plastics, every type of plastic, in PP, PE, PS, ABS, PET, PLA, PA. So modifier-based rubber, natural rubber for all that. So there are other types of plastic as well. That's the biggest advantage. It's compatible to every plastic, virgin or recycled. There is a case concerning the development that we had concerning sandals to use on the shores. You see, it's 100% circular. The stripes and the sole in therpole, so they don't break. For that, you have to stretch them 8 times its size, so there is no breaking, and they are circular because we are developing a project for our clients where we produce the therpole. Therpole is sent to the manufacturers of sandals. The sandals will go to retail, and with education and communication, we have that in the retail market. That's the differentiation. We develop to us the manufacture of the material. So we are a chemical industry and we don't have any contamination. We have the regaining of the sandals and we recycle and transform it in a new sandal. And so you see the balance. It's easy to do this process of regaining, recovering, and keeping the stripes. See the example. As you see, this is a case. Rubber sandals, very famous. They don't form any stretching that will disintegrate. So the most famous brand normally melts. We are able to prepare a blade and we are able to recycle and have a new sandal. So it's totally circular. Talking about plastic. Careful. And the circularity of the plastic. It's compatible to PP, PE, ABS, PET, PS, PLA, EPA, nylon. So we do the process with low temperatures, resistance to impact. So natural rubber has a typical point of cooling of minus 75 grades. So 5% of thermal, we are able to have less than 25 grades in polypropylene. The result is very impressive. So you see a part that is polypropylene, it's recycled, and as it is, there is terpol, and the difference is that terpol gives to the recycle another characteristic, and sometimes it's better than the origin.
Então, como vocês viram,
So, as you see, the first one was recycled, the first part, and the second one with terpol. It has properties that not even the polypropylene has in terms of flexibility concerning rubber. Another example.
Vídeos de uso do que propriamente as propriedades.
O efeito do terpol, the effect of terpol. This is with respect to impact in the case of the PP H30.
Primeiro, a esquerda.
The first one, 70, pure as it is, in terms of resistance, adding 20% of terpol, practically it doubles, with 50% of terpol. So 10 times more. And of course, when we use the superpol, then it becomes rubber. It doesn't break. So just to give you an idea how terpol interferes in the resistance to impact. To do that again, we are using for floors this material, and the terpol modifies the impact of the PP, recycled PP, and the virgin as well, when added to a modifier. This is the material with terpol. Observe.
A imagem fala mais do que as palavras.
So, image tells more than 1,000 words. So terpol resists or revives the polypropylene in it. It's another case that's very interesting. The long fiber. You see, this is for gymnastics. You see, there is no motor, and it was in aluminum with a rubber tappets, and we replaced the aluminum with rubber, polypropylene, and fibers, long fibers, and terpol, 40% of long fibers, and the rest in terpol. So it was 60 kilos lighter, the machine. And so we used a person to do the test that was weighing over 100 kilos. And we produced 20 or 30 mills that were exported to Hawaii. All the boards are 100% recycled. This, on the left, you have a PET, PET, that is virgin.
Virgem aditivado com terpol.
And there is the addition of terpol, and then the recycled one, also with addition of other material, and we developed that with another engineer, another engineering company. So there was the addition of terpol. So you see the virgin PET broke with the impact. The same, 20% of terpol, same material, 20% of terpol being added.
E agora,
recycling the PET and adding the terpol.
Aí são peças injetadas.
These parts are PET plus terpol. They are used and prepared by our partners. On the right, we have an example of the virgin PET versus a derivated virgin PET with terpol versus recycled PET with terpol. So the impact in this case, the use of PLA and articles that could not be used beforehand, the best way is seeing a video that presents it. So that's the pure PLA.
E o PLA com terpol.
And the PLA with terpol.
Aqui é caso de extrudado.
So, in this case, it's extruded, injected by extrusion. It's a plate done with 100% extruded polypropylene that is recycled. There is no virgin PET and 15% of terpol. See, observe that we screwed this part and it's there and is being developed to replace the MDF with many advantages and totally recycled. So it's a circular economy as well. So the clients that will buy this plate, they can give it back to the manufacturers, and in the sale, they would pay 50% of the value. We're developing that. It's a circular economy as well. This is 3D printing with terpol. The objective showing you that it's possible to do flexible parts with 3D printing using rubber.
Então é possível também produzir.
So it's possible to produce printing in 3D with terpol. We have a lorry with boxes of cables, electric cables that used to be in polyamide 666, and they broke easily when being bolted. And so with using terpol, there is more resistance to impact, bigger flexibility. It takes off the hydration process. So talking about nylon, polyamide, we have NICO, which is polyamide of vegetable origin. Petropol represents this material in Brazil, and together with Terpol, we modified the vegetal part. It was corn, and we are developing a hybrid project. It's environmental value awareness, EVA. We consider the disease, the carbon footprint. We have the vegetable polyamide modified with a biomodifier, ethanol. So it will be available to the end user with the seal of ethanol. So our company is a distributor of this product. So we are talking about Terpol and our big partner, Markeplan, and polyamide, the vegetable polyamide is being used here in the engineering processes. Concerning linear economy, the whole world, unfortunately, tries to produce it. So when people say the recycling is circular, no, it is not, because most of the times it takes more than 1 hour to do the process. And in circular economy, we have to extract, produce, recycle, and it's never disposed. So the others do the disposal. So the most varied types of plastic, they are part of the economy, but it does not mean that they are circular economy. The vases are examples that we are developing for the movie. We have vases using disposed material on the left side and right side. They were molded in polyethylene, terpol, and textile. And there is also an injection process of polypropylene in it. This is the tag that you see on the plastic. It's written, I was a uniform, and biotechnology Terpol transformed me into a vase. So when you do the scan of the QR code, you see the history of the product. So you are recovering the textile using the Terpol technology. We are about to close our presentation. I have circular stretches films to present to you. We selected some. They are circular, they are stretched, and it's 100% polyethylene of low density, totally recycled, and Terpol. It's another video for you to follow the process.
Ele também é circular.
It's circular. The stretching is 5-6 times its original size. It's green just to identify in the circular economy. That's why it's green. So we're having that in the retail. People are buying, acquiring the film, the Terpol film, and the pieces that are not used will be modified again. So we recover it 5 or 4 times using recycled PP and Terpol. So this is a development of a sole of a sneaker. We do not mention the name of the company, but you see the rate of vegetable carbon. It's 23%, so 26%, practically 1/3 of the soul in vegetable carbon, and it's 100% recycled. A detail, after 6 generations of recycling, considering the properties, they are identical to the original. This is the objective of Terpol. And to close up, we have a video that's been established and developed to present our thought concerning Terpol. Terpol is not a raw material only, it's a concept in terms of circularity. Many brands will use Terpol and they say, I want Terpol because it's natural rubber, it comes from rubber trees. So it's in the nature. In nature, we transform. Everything is transformed. It's a natural cycle of life. It's renovation. But there's something that is misled. We create objects that take centuries to disappear, disintegrate. Plastic, look around you. He's even where you do not see it. Plastic can be anywhere in nature. When you use plastic and you do not want to pollute, you're looking for a new plastic. A new plastic. The plastic of future. Because in future, you renew things. The plastic of the future has life. It's renewable. It's recyclable. It's sustainable. It's a cycle. It never dies. It is more resistant. It's flexible. It lasts more. It goes back and returns to where it should be. The future has less plastic in nature because it has plastic everywhere doing other things. Plastic of the future requires transformation. So, plastic of the future, Terpol. So we finish our presentation. I thank you all, online, the organization, people that are here with us, and I'm here for Q&A. Thank you to all. Thank you, Sidney. Thank you for your presentation. And both presentations of Vingo and yours. Now we have the moderators for the Q&A with our participants. Please, Claudio.
Okay, can you hear me? Just one sign. All right. Professor Jenskin, very nice, this use of additives. I'm used to use of additives, but rather as an antioxidizer or something like that. And what you've shown, it seems that a product has another action as a chain extensor, something that contributes for the size of the chain to keep the properties. Is it correct, or am I mistaken in this interpretation? Your microphone is closed.
I thought the question was for the other presenter.
No, it's for you, sir.
For me?
Yes.
Okay, can you repeat, please?
The idea is eu estou acostumado.
I am used to working with additives as antioxidizer, agents for crystallization, anti-static, the sliding agents. What we've seen are products that are dosed in high concentrations, 15%, 20%, very nice because they do not change the biodegradation properties, which I believe is fundamental for this whole process. But I'd like to know if there's any other benefit. For example, if I work with the product in a hot environment, in situations that are more extreme in terms of temperature, heat, if there's any change in color or perhaps a break of chain, loss of properties, stuff like that.
Okay. So in general, of course, the vinyl acetate polymers, they do have a certain temperature at which they would degrade, but the temperature is pretty high. It's as far as I remember, above 190 to 200 degrees Celsius. So you can really work over a very large temperature span with the polymers and the Vinex. It has also got to be added that the powders, for instance, are not completely transparent. So if you would add them to a transparent polymer, it would change a little bit. It would getting a little bit more opaque. But the 25 series of the Vinex is completely transparent. The 88 series has a very light yellowish color. And this comes, of course, with the benefits of the processing, but so you always have to check first what exactly, which sort of end product you want to work with. Should it be a transparent foil, or should it be some other piece of plastic which you use as toy or as, I don't know, as to drink out of as a glass or whatever, and then you can choose the appropriate polymer. But that's correct. You have to look at the circumstances. Yeah.
Ok.
All right. Could I think as being a chain extensor, or would it be a blend?
It is more a blend. So the polymers are blending together, and basically, of course, there will be intermolecular what's this in English, forces which stick them together so that the properties are enhanced. Yeah, it's basically a blend of the polymers. Yeah.
Ah, que ótimo. Obrigado.
Excellent. Thank you. Since we think about packaging, discardable packaging for foods, I believe that FDA, European Community, food approval, everything's okay. No problems about it.
Yeah, we have. I have shown you one slide where we had all the FDA regulations and the EU regulations. So for most of the products, yes, there is a food regulation approval available. Yes.
Ah, que ótimo.
Oh, excellent. I don't know if you can see me, but this mug, yellow mug back here is from PLA. People talk about biodegradation. This mug is 10 years old.
Okay.
So that's the point. If it's not well prepared, there's no point in saying that it's biodegradable, because it has to be in ideal conditions to do the composing, and that the living organism can consume the material, the product, right? I had yet another question, which is the following. Brazil is a country which has a strong concern with costs. When I put this additive, its impact in the final cost, will it be too high? Do you have an idea? Just a reference for us to know.
If you would like to get an idea about the costs, I actually have to refer you to our office in Sao Paulo, because I'm taking the scientific part and my colleagues there are taking the economic part. I'm sorry for this.
Okay.
That's all right. Thank you very much, Professor.
Thank you.
Sydney, there are some questions here about your product. Enhances the product's impact. The first one is the following. An application for food, such as primary packaging. Do you have any approval to use it, to use this product, or do you not? Good afternoon, Claudio. Thank you. Counterpoint was launched a little before the pandemic. And the focus was not for food. We are looking at it industrially. We went to Adolf Lutz, that's an entity here in Sao Paulo, for food grade analysis. We filed for it, but we don't have a final result. And all the components of Turpo undergo SGS. They have been approved in SGS, and over 30, 40, 50 heavy metals, toxic, and no raw material of ours has this characteristic. Basically, what we always see is the migration. We use natural rubber. That's why we are saying. So we have some interesting data there. For example, it does not have any toxic product in it or heavy metals. Many people ask about natural rubber being allergic. You go to hospital to do an examination on natural rubber. That was asked by a customer in the United States during a visit from Brastec in Pennsylvania, where we asked about how natural rubber is regarding toxicity. That was demonstrated. We have dermatologically tested approval, a high quantity of natural rubber, encapsulation of thermoplastic. It blocked any possibility of allergy. It was tested and proven. So those are the tests, even of vegetal carbon. We have just received from the Fluminense University a part we developed with high contents of terpol, and it met what we had of natural rubber in there, which corresponds to vegetal carbon. We made to have terpol grades with very high natural contents of natural rubber. So those are the reports we have ongoing. But the product is very new. We started developing it before the pandemics, and everything developed basically through LinkedIn. It's incredible, but today we're present in all continents through projects and getting through LinkedIn. And the result is marvelous. This is very good. I raised in the countryside in the city of São Carlos. I am a famous redneck. Oh, I got married there. So you're a lucky man. Oh, you Avenida São Carlos and the cathedral. I'm from there. And here's the deal. I vaguely remember rubber having a characteristic smell. Does this product, when you add it, does it give a different smell? Because polypropylene doesn't have any. Well, natural rubber has several types. We got the purest grade. So if you take the grade that the odor is very strong. So we could combine natural rubber in a way that, why can't we go to high contents of natural rubber in terpol when it's in contact with food? Because of the smell. There's no way of removing it. So we have this 10%, 15% of terpol and containers that at the moment of the injection, we realize that there's some odor, some smell, and after 10 days, you can't check any smell. So we have to make this balance. You're right regarding this concern, and it's also one of our concerns in the food sector. The others, there is no thing to be a hindrance or smell or trace of smell natural rubber. Okay, you've commented about migration. It seems that there has been not detected any migration when we do 15-20% of terpol and polypropylene, is it? As I said, it's ongoing. In water, there was no migration after 10 days at 70 degrees Celsius. If I'm not mistaken, the index was 1. Now we're waiting for results in ethanol. One other question. The last question here. When you have resin too many times in recycling process, molecules break and times change, they diminish size and they enhance fluidity. Did you do any assessment? Because when we work with anti-oxidation, normally you do several stages to see how much the material was degraded during the process of transformation. So I'd like to know if with rubber, due to it being more flexible, you have any gain or anything. This case, we're developing one of the biggest sports brands in the world and totally recyclable side. We measure the seventh generation of injection recycling, the second recycling. We're talking about pure terpol, not as a modifier of impact. It practically didn't lose anything in terms of properties. That is due mainly because of the question you asked. You actually Dr. Ying. It's natural to have a gigantic chain. The chain is enormous. So when you put that in plastic, you bring dead plastic back to life. You saw that test. One would break, you put 15-20%, it becomes flexible. And that allows a lot more recycling without losing properties. We've seen that already. Well, this is very good. Now, it changed the characteristics of the plastic a lot. A question that came up to me now because I'm back on the race now. Back on running now. Your use of sneakers is fundamental, especially with lots of flexion. You seem to have tested with agents for blister formation to do some with blisters. We are only manufacturers. We are the only manufacturers of gas carbon acid. So we have experience with expanded MPA, expanded rubber that's very big. The biggest detail that we have, for example, this sandal here, this flip-flop. The base is synthetic rubber with expanded terpol. We could give it great lightness and lots of resilience. Due to the use of terpol. And now we're going to the injection to improve, diminish the impact of injected PVC that has enormous volumes in sandals. In this case, this is rubber. The biggest known brand in Brazil is rubber, but the second one is PVC. So we have very advanced work in the reduction of quantity of PVC in combination with terpol, precisely for it giving this characteristic. In the case of intersole for sneakers, it is work that I cannot review due to the secrecy we have with the brand, but we're working on that. It is good because sneakers with stability to run is very good. Alan, I think that those were the questions that we had. I don't know if there's anyone else who would like to ask. Julia, if you had a question, we're open here. If anyone would like to ask a question, those who are here in our chat can ask. And I have some questions here too. We have a little time. So I'd like to know from Dr. Nico if we have users for those additives in Brazil. Dr. Ingo, do you know this information? And what are the main applications in Europe of such additives? It's a big array, wide array of injected, but I'd like to know if there is one specific application that is prevalent for those additives in Europe.
I would say that, first of all, yes, in Brazil, we do have a couple of projects which are in the development stage, and where customers or potential customers do tests with the products. In most cases, I can say that the major polymer people are working with is the PLA, because the PLA is very broad. This is the biopolymer with the biggest volumes currently, with the biggest application, and a very long history also of technical expertise. So for our case, where a lot of people do work are especially for the production of packaging material for all different sorts, and also for paper coated with PLA in order to make it more stable for instance, for one-time applications like drinking coffee out of cups. This would be also a very famous application. And as I've already shown, this process where the plastic bags are being made is also because quite some customers are working also on this. But we do not also understand everything, because also the customers have their own, let's say, privacy and the secrecy when they work with on their compound. So we only get part of the information as well.
Okay, thank you.
Okay, obrigado. All right, I have a question for Cine. Cine, we've spoken during Interplast. When I got to know Interpol, and a doubt that came to me is it's rubber, but in the process, it is thermoplastic. Explain to us how it works. Which processes can it be transformed with? Perhaps this is a recurring doubt of the industry. All right, thank you for the question, Alan. We get the natural rubber from the tree, transformed in thermoplastic. We combine it with some types of plastic, and we pelletize it so that we can do it two ways. One, adding directly in the funnel, mixing with PP or PF. When you have products that need heating, for example, we did a part by injection bro of PET. So how did we do it? First, we had the PET prepared that went into the extruder. And in the first edition, we got Terpol there. So we mixed there, and there it went. Or the manufacturer, as Petropol, our distributor, manufactures plastic compounds for engineering. It composes plastics directly. In the third case, I cannot open this information, but in May, there will be the production of the first plastic in reactor modified by Terpol directly at the petrochemical. So it's going to be done directly. Those are the three forms. The biggest detail, it's to get a rubber and transform it into a thermoplastic pellet is something that's not. It demands. We are rubber makers originally. We're an industry that produces additives, 95% for the rubber. And so we have rubber laboratory, then we had a plastic, put them together, and then we had the ball. I would like to show an example of recycle. This thing here, it's a little yellowish because of Terpol's natural rubber. This is recycled and was opened, closed over 1,000 times. And it's still here, the clicking. So it adds those properties. And we opened sanitizer, 3 openings, you break it already, the lid. Here you can open, close, it's never gonna close, break, and it's recycled. So, precisely to understand, it's a mix that the plastic process with the rubber process. Okay. Thank you, Sidney. Claudia, would you have any other questions? Would like to close? I'm a technician, so I would speak two boring topics. I think it's nice. Thank you for your presentation. It's very interesting. And I think this is the future.
Thank you.
All right. There's no one single solution. You see the presentation from Dr. Ingles, you get the Paul's presentation, they complement themselves. There is not one single solution. And the forum, this chat, is to gather people with ideas and have new ideas appearing. And since we are all technicians, ideas that are flowing. It is interesting because what you said, if we could get what was spoken in the morning, could get that material that is exposed, that is in the landfill and people don't know what to do with. I got to see people throwing BOPP away because they said they didn't have way to use it. That's a marvelous product. If you clean it, it's very good for use. And with this technology with you of enhancing properties, you do a new product. Obviously, you don't need for food, for a series of other applications. So you have to work a lot. Because when education takes it, we're going to have lack of raw materials. That's it, folks. Very good.
Thank you.
So I thank you all for your presentations.
Goodbye.
I'm not getting back to Claudio. Claudio has closed already. And we're going to close this panel. Thank the participants for the discussions of the improvement of the properties of the bioplastic. We have some minutes left, and we're going to now reproduce some videos of our sponsors while we wait for the preparation for the third panel. Thank you very much, everybody, and see you all soon.
A gente não consegue acelerar o tempo, mas podemos acelerar ainda mais as nossas ações, usando o tempo que nós temos hoje para transformar o futuro. Por isso, a Braskem, alinhada com os Objetivos de Desenvolvimento Sustentável da ONU para 2030, assumiu novos compromissos com as pessoas e com o planeta. Trabalhando em 7 dimensões diferentes, temos muitas metas para os próximos anos. Entre elas, a eliminação de resíduos plásticos, a ampliação do portfólio I'm Green, nosso plástico feito de material renovável e reciclado, a promoção da diversidade, equidade e inclusão e a neutralização das nossas emissões de gás carbônico até 2050 para combatermos as mudanças climáticas. Vamos transformar o mundo em um lugar mais sustentável para todos, deste tempo e dos próximos. Braskem, um futuro mais sustentável hoje.
creating tomorrow's solutions.
Bioplastics Brazil. Voltamos a lembrar que após o próximo painel será disponibilizado um link no chat com o formulário de inscrição e avaliação para emissão do certificado de participação. Todos os participantes que preencherem o formulário receberão o certificado pelo e-mail cadastrado e poderão também solicitar o envio das apresentações dos palestrantes. A sua avaliação e seus comentários são muito importantes para que possamos aprimorar o conteúdo e de forma que ele atenda ao máximo a expectativa de todos. Vamos agora para o painel 3, sobre economia circular, e eu gostaria de chamar à tela a moderadora Karina Darwish, da Abicom, e da K. Darwish Consultoria, e os palestrantes Yuri Tomina Carvalho, da Braskem, Emanuel Martins, da ERT, e mais daqui um pouquinho vai entrar o Inácio Parada, da Bioelements. Inicialmente eu vou
start the interpretation with the presentation of Karina, that will be the mediator of this panel. She is industrial chemist and with MBA International Commerce via USP. She works with Feiras USP on sustainable projects, operational marketing via SPN, and polymeric materials via University of Santa Cruz. She has several years of experience in marketing and technical issues, covering market of polymers, commodities, plastics, biopolymers, composites, and inks. It's also a director of a corporate focus on innovation and markets, and is also the executive director of Abicom. And she is part of the Regional Council on Chemistry and responsible for a pioneer project of composting, considering a case of success in circular economy, sustainability, and innovation in 2015 via Pacific. Karina taking the floor as the moderator. Thank you, Ellen. Congratulations, Lucia and Ellen, for the excellent event. It's an honor to contribute with the technical support to this international seminar. Talking a little bit about Abicom, because in the morning has been gone via Verusta, our president, and we're talking about composting biopolymers, working on the dissemination of information about the composed bioplastics and composting process. To know a little more about us, Abicom, visit our website or use the social media. I would like to introduce you to the subject, giving my greetings to the afternoon persons, Yuri, Emmanuel, Yassin, Ignacio, and good luck with your talks. And good afternoon and welcome to the participants that are here since the morning, people from several regions in Brazil and several countries as well. So talking about circular economy, according to Ellen MacArthur Foundation, it's so we're talking about disposable material that can be used in the new cycle, the technical cycles and the biological ones. This industry is in transition. So we are focusing on the use of plastic with less impact on the environment. So we have to reduce and eliminate what's not necessary and innovate to guarantee that plastic is reused to its most recycled and composted. Bioplastics are in this economic concept because they break the linear economy. So just use and dispose, doing it more circular, using, reusing, and recycling.
As part of the bioeconomy, examples of circularity, they regenerate the CO2 and use raw material of renewable sources. These are the bioplastics. Now, the experts will take the floor, and Ellen will present the first talk with Yuri of Braskem. Have a good event in this panel. Thank you, Karina. It's a pleasure to have you here as a moderator, and we have Yumi Tomina Carvalho of Braskem that will talk about design concerning circularity in wrapping or packaging. He is an expert in market and green brand for South America. He's a leader of a team of experts to develop business and innovations concerning circular economy referring to plastics. He started at USP and has over 15 years of experience in the petrochemical industry, here and abroad. Welcome and take the floor. Thank you, Ellen. Thank you, and Lucia, for the opportunity, and Karina for the motivation. And I think the theme is very special, of a special interest, not only for us in Braskem, but for the industry as a whole. So, can you see my screen? My presentation is on the screen. Can you see it? Are you seeing the slides? Your presentation, please use a full screen. I'll try again. Now, yes. Okay, now it's okay. Please carry on. When we talk about circular economy, especially with low carbon, so we cross several points. How do we maintain this resource? How do we bring it back to the production chain, closing the cycle? And we understand in Braskem that it's fundamental, this transition from a linear economy that's being developed since the Industrial Revolution, 300 years, using the same model. How do we do this transformation to a new model? Our understanding is that design will be a key role in this transformation. And I'll talk about packaging, but the valid aspect here is that all the products and the packagings were developed up to now, considering the standardized model till then. So when we understand the transformation of a linear economy to a circular one, especially with low carbon rates, the redesign of the products and materials have a fundamental role to be part of the products with new concepts. Why is it so important to have this design in this context? I will present very simply a study in Denmark. 80% of the environmental impact of packaging is defined in its concept. So when we start the concept creation, first ideas 80% of the environmental impact is fixed. So we have to bring that in mind to the process, considering the environment of the design. What are we doing? We understand the importance, and we bring it to the strategical concept of Braskem, specifically in the packaging segment. Since 2018, we're working on this platform, design of circular packaging. What is it you bring to the development process? Information that is strategical for the development, considering the reduction of the impact on the environment. We do it using mainly the tools and the scientific data that support this direction. And based on this direction, where are the impacts? We look for alternatives for development, creativity, design, to find the best solution that optimizes the packaging system. So considering the life cycle of the packaging, and mainly bringing a combination between the technical analysis, quantitative analysis, where are the impacts on the environment, adding quality as part of the journey, consumption, how the consumer acts in contact or performs in contact with that packaging. So the connection of these two units, the technical one, and combining it with expectation, experience, and preference of the consumer, then we will bring especially since 2018, Braskem is focusing on it. For that, we developed a methodology that's proprietary design for environment. It's a form of doing this combination using tools, combining these two universes, technical, scientific, and observing the performance and behavior of the consumer. This methodology, we are able to develop solutions that will bring a systemic view for the problem. Is the briefing, is the concept, addressing post-consumption solutions, observing the environmental impact. So we see where we start, what are the challenges, where do we want to go. So we check the progress and evolution via this development. Since 2018, we are working on this model, this methodology, and we generated several cases of co-creation with some partners, some examples on the screen. Solutions are in the detailing stage, executive project, so we cannot show the result yet due to the partners, that are looking for solutions. But we see results that are very expressive concerning reduction. This methodology guidelines. So
a view of long term, we're working on it And Braskem is also cooperating in the chain with the clients to generate sustainable alternatives for the packing, ready to use in the market to start this process of transition. And I bring you some examples. We are developing, together with partners and clients, solutions that are with single materials, so we can recycle the packaging, being it in different sizes or material, inflexible packagings or not. So we are developing solutions that incorporate the recycled content, giving added value to the discarded packaging and presenting a new solution as we develop with Coral and hybrid bucket. So 3 companies together with recycled content, not only in polyolefins, in PET, and also in solutions that are monomaterial, BOPT, or lamination of other materials that will favor recycling. The 2 fronts, co-creation, more complex solutions, finding alternatives, ready to use in the market. To do this advancement in the market, having circular economy, we developed cases. I'll bring you one, which I think we should comment concerning the technology that we presented, partnership with Tilias, the launching with Mãe Terra, which is of Unilever. So it is the monomaterial of Unilever in Latin America. So 100% polyethylene, no type of lamination, totally recycled. And when Braskem and Antilles took it to Mãe Terra, Mãe Terra accepted it and was the first to look for a solution for the consumers. We understood that the value of a new technology, it happens only if you use the packaging and put it in the end of the process of recycling. So we have a partner that took part in it to close the cycle, to help Braskem, Mãe Terra, and Antilles to complete this cycle, fostering the consumers to bring the packaging back to the molecule collection point. So it's cash back. So it was good because if people take the packaging back, they have cash back. So the molecule and the packagings are with Braskem again, and we develop a 3D print resin using the recycling of this packaging. So this case is a symbol. Since the conception of a technology, the design of the product, packaging, to the process of understanding and fostering the consumption journey, we work with cooperation to create cases that are really circular. That's what we are focusing along the years, creating this innovation ecosystem for circular packaging and our products. Yeah, I've seen Alex presenting it, talking about I'm green and the other variations concerning recycling, renewable plus recycling. It goes beyond. You have to contact startups that are bringing new business models, do the acceleration, looking for tools, having partners in the development, infrastructure, innovation in Braskem, here or abroad, mainly our most recent investment in Rio Grande do Sul state, which is a recycling aisle, which is very important in the co-creation of these solutions and the assessment of these developments. So I mentioned some tools, but we have to consider mainly the partners that are engaged in these programs of co-creation in the sprints of innovations in order to find new circular solutions. We are understanding that this model of co-creation and this ecosystem focus on circularity of packaging, it's gaining the attraction of the partners and important results in terms of development. That's why Braskem has launched 2-3 months ago something else in this direction, the creation of a development center of packaging. The name will be Kazul. So it will be a space, a lab of design focused on circular economy packaging. Innovation Hub, the brands, the companies of the packaging chain, which are our clients, startups and designer companies can work together to develop the new solutions. The challenge of transformation in linear economy or circular is not something that a company will do it alone. Cooperation among every link will be necessary and fundamental to cover all the challenges that a transformation as big as that imposes. So this understanding leads to the motivation of having an innovation hub where we meet and cooperate and work together in the creation of new solutions in the circular economy. What do we have? It's more than a space dedicated to co-creation. Build a vibrant circular economy packaging ecosystem is our focus. We will have at your service all the tools that are developing in terms of methodology, design, DFA, the life insurance, so simulation, modeling tools to make the process easier, mainly approval and homologation of new solutions. We'll have a space dedicated to startups and designers that will develop new alternatives, considering the circular economy drive and more economy in terms of packaging, and mainly a prototype lab where we can do things very fastly. And so it will go via validation process quicker, using the brands and speeding up the solutions in the market. This space will be dedicated to every chain of the developing process, focusing on prototyping, looking for what we call validation of the market fit, So new alternatives, new technologies that are generated can be taken to this space, cooperation space. It will be tested, assessed, and validated. And then when we find the solution that is validated and certified, we have an infrastructure of Braskem in the Innovation Center or with the partners to do the tryout phase, the pilots, and the quality tests and certification to guarantee that we have a solution that is adequate, sustainable, and real, that can be scalable and answering to the technical requirements and competition that will reach successfully the end users. The center will be as a hub, innovation hub in Vila Leopoldina. This is focused on a hard tech, so it's physical, not so much on software. And in this environment, we have this connection that's very important. It's close to Braskem's office, and the ecosystem is expanding easily with other players of the corporate world or a pool of startups, very expressive, that are already there, or venture status, active and fast-growing ecosystems. So that's what I had to present to you, to share with you today. Not much. I thank you for your time and attention, and for the opportunity to present the importance of this redesigning process in a circular economy, telling you a little bit about Braskem's investment in this way. Thank you, Helen. And
Thank you, Yuri, for your presentation. We're going to continue here. I would like just to announce something here. Inácio Parada from Bioelements will not be able to come. He had something, and he's going to be replaced by Adriana Jacomin, who's going to make Bioelements presentation. And now we're going to present here Emmanuel Martins from ERT, Earth Renewable Technologies. And Emmanuel is going to talk to us about greenwashing, information to be taken into account when choosing material for your products. Good afternoon, Emmanuel. I'm going to introduce you briefly here. Emmanuel is a mechanical engineer graduated in Vision Systems. He has a career developed in petrochemical and plastic career with 20 years of professional experience in injection, working in strategic functions involving management of business and development of structured solutions for the industry. Since 2016, he is responsible for the operation of Earth Renewable Technologies in the United States, responsible for development and application of PLA compounds and drop-in solutions globally. Right, Manuel? Thank you very much. Tell us a little about greenwashing, please. Thank you, Alan. I'd like to first thank Lucia for the opportunity. Thank Karina for the narration. And I'd like to thank Yuri for having given us so nice panorama of what Braskem doing for circular economy. I think I couldn't agree more with him. And another one says that we don't have a single solution. We don't have a silver bullet that will start from a linear economy from day zero and get to circular economy on day one. So we here in ERT, we work with another part of the solution in different cases. Today, I'd like to talk a bit about this part of this greenwashing
we who are fighting for circular economy to happen, I think this is the greatest enemy, which is basically the difficulty that the brands have to understand what is really sustainable and what is not. I think that we play this role. We, as plastic generation, we have this obligation of delivering a better baton, more circular than what we've got. And that's why we end up having to speak about this topic. I think that greenwashing is a phenomenon that started basically in the beginning of the 1990s in the United States and expanded greatly in the 2000s when companies started to understand that consumers were looking for more sustainable solutions. And then we started a search without parameters and often failing in the pursuit of the solution using maneuvers or phrases from market to solve the problem easily, not trying to get into the discussion as a whole. So, I think that the main case of greenwashing that we can mention, which was perhaps the biggest case that has happened, was Volkswagen's in the United States when they launched a campaign called Clean Diesel. And there was the advertisement that the car would reduce pollution, emission of pollutants, that it was new, etc. It was big sales success. And of course, it was discovered in some years that no, everything was forged, the number didn't exist, and due to this, Volkswagen was fined $400 million. And that has left us an important lesson, which oftentimes we can't take shortcuts in sustainability. We can simply say, oh, we're solving the problem and the solution is A, without put anything there, we're going to solve the problem. I think this is very important to see the movement in our chain, often movements that are focused on solving the problem quickly, and that ends up generating more problems. And there's greenwashing that we can say that green advertisement or something like this. So, the 5 biggest types of greenwashing that are the undue use of images. So, you put an image, something natural, and something that is not sustainable, or that's not doing any good, or is not keeping the environmental risk that existed before. The labels or the information being confused, that is, right, oh, this product is 100% vegetable. We have not tested it. There is nothing that says that this really happens. And nothing that really, let's say that really has any depth in it. The type is simply hiding a trade-off. So I think that for us, one of the most common examples today are brands that put, oh, this is a recyclable product, and it's not, and it's never going to be recycled. And then when this is going to happen, they simply keep the claim and put in there and think that then the government. Today we have an example of California that got to solve those issues, which were issues if everybody knows. There's no point in continuing doing this using this name. The fourth type of claim is the claim which is the company is forced to do the test by law, but they continue writing that they continue, oh, I do this test, but you forced by law to do it. This, we have an example of some clear examples and when it happens. And I think the last type of greenwashing that we have to avoid at all times in the industry of packaging, in general, is the smallest of the two evils. It's, oh no, but this is a little better, but continues being bad. That's okay. We pretend it's there. So I think this is something that we have to work a lot with. Precisely what Yuri commented in his lecture, you have to start measuring. You can't simply say, oh no, but this is better. Under which criteria, in which perspective, which analysis? If this analysis doesn't exist, we're just changing A for B, just to say that we changed it and use it in our face. Checking that the European Union in 2021, they said that 50% of what we say as sustainable has lack of clear evidence for such. So we have examined 344 different packaging, different types of products, and half of them, the suggestion of what was being written that it was sustainable, greater awareness, that was not sustained with practical evidence. This is what we clearly see. This is a problem to be understood. We have to give the brains this knowledge to make everything be a lot more evident, because once you start using words like green, sustainable, you have evidence to prove it. Otherwise, we'll start just creating more problems than solutions, because we will really messing up with the consumer, not happening. So I think everyone has seen this. We have this problem of greenhouse effect emissions due to the production of fossil plastics. I think this is a problem we have to tackle in the years to come. We have to effectively move away from fossil sources. It's a big challenge, but it's a challenge that we have to face. We know the problem already, and we have to be able to neutralize our carbon emissions and try to replace it as much as possible, fossil carbon by and one, so that we can produce the same quantity of plastic, that is, we can continue packaging the products, continue caring for the people, continue doing the same things. But I think that it's important to always do it differently. This is just a statement to close the part of greenwashing. I think it's important we work with really biodegradable products. There is a problem that we need to address. There is no point in leaving it behind, which is oxo-biodegradable, which is oxidizing additives that are used in polyolefins and in polyesters to diminish the size of those products. The fragments left by those plastics in the world do not allow them to be consumed by microorganisms, and we're just generating more microplastic, more negative publicity for our chain. I think that we, as plastic industry, we need to understand this, that a solution is an issue, we need to solve it. I think this is a problem that we all like to focus on, we have to address it. We cannot continue creating problems otherwise. I think that it was in the media, was this, the plastic in human blood in the oceans. We know that all that is less of exposure. No plastic bag walked into the ocean, you see, but there's always a failure too when we want to put additives in polyolefins and allow this to become microplastics. Anyway, what we present, our part of the solution to this, is into bioplastics. So in the seminar here, our focus is presenting what we understand as a solution for the chain and what are we doing for this. What we do here in ERT is basically work with bioplastic of renewable origin and compostable end of life, which means that we work from the origin of the product, where we get this carbon from, till the end of its life, stimulating the composting chain, stimulating several processes that today have the recycling quite very difficult to change the type of garbage to leave. The recycling say, let's put in compostable. Let's put it together with 40% of the garbage that we generate organic garbage. I think that we have lots of products, lots of packets, lots of single-use plastics that need to be discarded by compost and not by recycling. So we understand the complementarity of the solutions and we put clearly the need for those solutions to exist. Here at ERT, we basically work, I think that everyone has seen in this whole seminar, the definition of bioplastics. This is the focus, but in this focus, I want to explain that we work with blends and compounds of PLA. So our raw material is a gas plastic polymer generated from sugar, and at the end of its life, it's going to be composted industrially or residentially, depending type of product that we manufacture, depending on the weight, depending on what you understand being necessary. Today, we have 4 developments that we launch in the second semester in Brazil. It's going to be the first compostable packages here in Brazil, and we're stimulating very strongly the compostable chain so the customer understand where to focus so that this won't go to recycling, so it goes directly to composting. So we work basically with which is a polymer which has its almost neutrality in the production in terms of carbon footprint, and we can make neutralization at the end of the packaging. What is this possibility of the circularity? We understand as this. The PLA is going to be compostable at the end of its life, so it's going to generate carbon gas and water, the 3 compounds that we have at the end of the PLA's life, and the emission of carbon gas, the offset is very good. So it's very worth it. Our main focus as products and company is to focus on single-use plastics or packages that consumers will have to discard after use. We understand that in terms of weight, this is difficult to do reverse logistics, so we work strongly for consumers to change this into a circular economy and that they circulate this into composting. Also, we're going to have the option of recycling PLA. It's also a viable option in products with greater weight, where the logistics is feasible. So, speaking a little about specifically certification, what we see, how to escape the greenwashing or how to escape the brains not making those mistakes. I think that today we have two big groups of tests. One group focused on the United States and a more international group. So we have BPA, Biodegradable Products Institute, the TV Institute in Austria, certifying all materials, trying to find the best way of labeling this product and showing why the product is certified. So, in the United States, we have STM 1346, in Europe we have 1343. There are two big groups of members, STM 64 and we're working strongly to validate the Brazilian norms, and also that we're basing ourselves on norms. In international certification, we have some groups to certify domestic composting, to certify that like plastic is going to be in the composting in the industry. And there's three big attempts. And then we have another one in France that 1,800. We're testing domestic, and we have only 1747 in supermarket bags, so that they can be residentially composted. In the United States, we have a norm to landfills. Internationally, that's not clear, but landfills have very different criteria in Brazil. We have a lot of landfills that basically are more composing than landfills. So we have here in Brazil, we still need to have some change in this problem. And marine biodegradation, which is the biodegradation of the oceanic environment, which today is well established, despite of the fact that we, as a company, continue understanding that plastics should not, if possible, shouldn't be tested for the marine degradation, because that's not a focus, that is not a idea to degrade the material in our environment. The focus is that we degrade it in controlled environment. Anyway, there is still we can certify materials such as biobase that is certified so through carbon 14 test. It's also very nice. It's important that this is well certified, well very clear to the consumer, so they can understand clearly what they buy and how this is working. So today we certify a lot more by international organ. We follow 42. Despite we have some materials certified by DC 46. So today we understand this is going to be very important, and it's going to be increasingly important to make those issues of certification known. Once the growth of bioplastics is around 25% yearly, and we will have to explain to consumers what bioplastics are, what they do, what is the focus of the bioplastic, and what is the reason why we have to use them and how they're there. I think those are the key players of the plastic market. Braskem, I believe, is the biggest player today. It's a non-compostable plastic, but it's renewable in origin. Then is scientifically different TSNV with PLA. So, for you to understand where we are positioned, I think that we are still a small market compared to petrochemical, but we have a gigantic challenge to get the scale. All of us, we have to fight to get this demand of production. And then, speaking about what is the future, again, till 2025, moving ahead from tip to 2030, I think that today we have this integration of PLA compost that we do here. And we today receive basically sugar to do this. The focus of the future is that we should work the carbon that is in the spice today, but we should start working in the materials free of cellulose. For example, the bagasse of the sugarcane. We're going to do a process. We see starting in 2025, we do the first world producer of biopolymer of second generation. We're going to do it from sugarcane bagasse. We're going to do hydrolysis, fermentation, and polymerization. So this perhaps meets a demand of the consumer, current consumer, to try to scale the competition. So when we don't compete, bioplastic, and we have raw material that has more availability. And the second generation plastics okay, folks, it's here. Thank you very much. And we'll talk again later. Thank you.
Thank you, Emmanuel, for your presentation. And we will carry on with the presentation of Adriana Jacomin, that is replacing Inácio Parada. Good afternoon, Adriana. How are you? Adriana will talk about new business models involving bioplastics. Adriana briefly, she will occupy the position of manager in Brazil, and she introduced a new market possibility in Brazil. She's graduated in Porto Alegre and has a multicultural experience. Since its foundation in 2014, Bioplastics progressed a lot. It is present in 7 countries and is among the awarded companies both for global and last year's award as an emerging company. Eventos is among the 6 most promising startups. Adriana, tell us about your company, what you do concerning bioplastics. Taking the floor. Thank you, Evelyn. I thank Emmanuel, Yuri, Karina, and Lucia that invited us. Very kind person. I'm here to tell a little bit about how our company performs in this country. So, our research in the country is very recent. It's new. So, this is an evolution of the last years. So, when our company decided to establish in Brazil, we studied the market, and Bioelements has a very interesting story. And the innovation in terms of bioplastics. They have a new line. I'll tell you a little bit about it.
new business model involving bioplastic. Please put it in full screen. You need it in full screen. Can you alter? Okay. Not yet. It's not in full screen yet. Now, yes. Thank you. I have 2 monitors. I'll talk about the new business models involving bioplastic. Talking a little bit about bioelements, tribal impact on the industry of packaging, and we are now following here in Chile the standards concerning the use of plastic. We are developing in 2017 new products. There has been a study, and in 2017 in Chile, we have now a good cover of the market that we sell to Mexico, El Salvador, Colombia, United States, and now Brazil too. And our CEO, José Inácio Parado da Fonseca, he is of human resources area, is a lawyer, but he wanted to be an entrepreneur and work with circular subjects. So when Juan Eduardo left, José Inácio joined us. He wants to build a new product, and this company that was established in 2014 looked for alternatives. Why did we do that? Because we had a problematic worldwide level. We are not able to reduce the CO2 level, the pollution of waters, environmental pollution, complex waste being wrongly managed. So alternatives to mechanic recycling had to be considered. In Chile, Peru, and Mexico are main markets. And we can extend that to Latin America, including Brazil. In Brazil, we recycle 3% of the waste, and we can reach 30–40% with work. So the plastic that will last in the environment so many years, if we recycle, we have the waste aisles. So most of this material will go to landfills, as Emmanuel has mentioned. And how this company could help In 2017, our conventional form started with biodegradation. So bioelements started the innovation with conventional plastic, 400 years or so. Bioelements products, 60 to 20 months, and biomediate resin. Also involves bio-based, renewable, and biodegradable products. It's biodegradable because it happens with the diminishing of the amount of grams. It's very important to emphasize that it's biodegradation. That is not another process. It's not disintegration, it's biodegradation. So we have to combat pollution and save the earth. As we said, we started in 2014 with a bill. So we suggested that we had a new rule concerning the use of packaging of the supermarkets, the bags used in the supermarkets. So the question was, let us say if we have all this product in the landfill. Of course, it's a very tough question. We developed products, as we always did, University of Chile, as a partnership, etc. Developed more and more products, biodegradable, non-toxical, etc. So the community started working on it. We had many issues to get the result we wanted. And we noted that biodegradable product directly with the presence of oxygen, you have less products in conditions that are not considered adequate. So in conditions of compostage, we have in low and high temperatures, and considering the environment and the sea. Imagine if you have all that plastic on the shores, on the cliffs, where there is no contact with other things in the decomposing. So biodegradability and without the presence of the oxygen in conditions of landfills with low temperatures. For instance, what you have every day, a process of degradation in masses. If you leave it there as it is, it will disappear with time. What happens with the mass? They are transformed in the environment. It's biological mass. It's bio. So it depends on the concentration of the oxygen, of course. So it's a segmentation of our end product. So, of course, degradation goes slower. It's a biological product, but it comes to happen. So, concerning the environment, the sea environment, the product there in the ocean, it's not the right destination, but it happens. So we have to have emergency actions to avoid it. The idea is recycling all the plastic, but it's impossible. It will take a lot of money and time. So there is a movement to reach with the biodegradable plastic diminish quickly. This transformation can be quicker if we dedicate ourselves more. We do not want to alter in a negative way the products. I will not mention all the products to you, I'm going very quickly, but we have a product that in contact with earth, it improves the earth. And we have no toxicity in our product. It's a product without biotoxicity. So they do not alter negatively the environment. We are a company that believes in the economic impact, social impact, and environmental impact. And obviously, this is very important to note. So we are part of the development promoted by the UN. It's the sustainable objective. How can we focus this program? Via the triple impact. Let us say we have to customize, innovate the packaging, the biodegradable ones, composting products. So we have to observe the retail, the packaging, several types of bags, the industrial product. It's new for us, one of the last areas that we focused on. And it's a project that is very good. It's a step that the company has taken, looking for recycling. Let us see, packaging for cheese, for bottling, etc. And we have to observe also our progress in terms of the agro business and the food business. In agro, what we have in agro business, we have many opportunities in innovation of bioelements via the triple impact. It's an alternative for the companies that want to innovate, to be in contact with the environment, improving it. Of course, they are oriented in this sense. So again, a little bit of the products that we work on. Our products can be customized, it depends on the client. And the link I wanted to do now is, besides being there, involved with plastic, we have to understand our position in the environment. Plastic per se, if you consider all the process of doing the product, recycling it, giving it back to the environment to be reused. It's not the case of our company 100%. So I will explain how we work. We have a Bio E8 design, bioplastic design, then the process of production, the bioplastic product, and then the creation of nutrients and the renewable raw materials, all that in this circle. So, in fact, so we have products that are being tried by the client. Some have been approved, some have not. And so we have a new differentiation. We incorporate the product to the environment. So it's not toxic anymore. And recycling organizes basically the composting. Just to emphasize an example of a company in our area, Australia Seafoods, giving the first step, sending salmon in plastic bags. And so it's our newest creation. We have models. Bioplastic. Australia signs deal to switch to biodegradable. The certifications on the screen, meaning security. We started very recently. We are a new company. And we are in very active zones. Of course, we are behind Europe, Mexico, Peru, but we have certifications that are approved in these countries. In a new market, it's very important to be certified. When we started in Brazil, our idea was finding the lab that could be a partner. Nowadays, we count with organizations, and we are developing our processes in Brazil. And I have to point out that we are using processes that are used in the United States in terms of food contact with the packaging. So FDA and Anvisa have a partnership. It's something that will be helpful in the certification. International presence in the countries you see on the screen. Our markets. And acknowledgement, certified B Corporation, Endeavor, a global company, and we are focused on the social impacts and environmental impacts that we may generate. We have the radar of behavior. So we are entrepreneurs. Our certifications, the last one was concerning innovation, and we share our work with very big companies in the market. And this is us, a little bit of us. And Inácio Parada is our CEO, and Mateus is our counselor. I am Adriana Giacomini. Thank you, Adriana, for your presentation. Now, I pass the floor to Karina, our moderator, that will coordinate the Q&A of the third panel. First of all, congratulations, Yuri, Emmanuel, and Adriana for the presentations. Let's see the questions. Many, we don't have much time. Yuri. 2 questions. Roberta, when the center will be inaugurated, and Adriana, what do I do to take part in Casulo? Good questions. I did not comment. We are building up. So it's the answer is in the beginning of the second semester. Till then, the best way to contact us is inviting everybody that is assisting us to check Braskem's social media. We'll comment about the inauguration for sure. And the email is kazoo@braskem.com. If you want to contact us, go deeper. Maybe it's just a simple chat before opening the space. We are there to answer to your questions. Check the social media. We'll be there showing contacts and addresses to interact, creating projects that will be the spirit of this hub. Proposal is having an open hub, so there we'll be able to create this ecosystem in terms of innovation. Thank you. Michael Machado asks, is the PET biodegradable? Oh, no. The PET, we do not have biodegradation. There are additives to start with oxidation, but what we are doing in our campaigns, maybe Yuri can answer it better. The MAG, that's part of PET, will do a bio-PET that will be 30% of renewable energy. Now, biodegradable, it does not exist. PET. Yuri, adding anything? Exactly. Let's also commented today about biopolymer of Braskem. This is just one renewable chemical front. So it is in the industrial scale. And the next one is BioMag, M-A-G. We have a demo plant in Denmark. And it's been launched 1 month ago. The MOU with Sujits to build 3 units of MAG, BioMag, using renewable sources. As Manuel has commented, MAG is one of the raw material. So it takes 30% of MAG, so it's partially renewable with the renewable BioMag, 30%. We owe that to the results of a unit that will start in 2025, and the construction will start now to reach the mark in 2025. Adriana Coletti. How will be the identification to the consumers, to the packaging that can be or cannot be decomposed? No, that's only that. Of course, it depends on how the companies will give orientation to the end user. So we will inform that the product has to be disposed and how is the process. It depends on the communication that the brand will start. It's a product that cannot be in the recycled, it has to be in the organic waste, but there is always, the good products always have indications in this sense, explaining where you dispose it. So there is a certification to clarify that as well, where it can be disposed. Emmanuel Alanine. It's a question from Aline Lemos. Selection concerning composting. Is the PLA is in the landfill or opened up? Won't it be worse? First, assorting follows the orientation in the packaging. You have to have it in the right place. Aline Lemos. Unfortunately, in Brazil, this is not a habit. People do not have many plants, composting plants, and not even domestically speaking, and not every product as well can be with the composting doing at home domestically. In the case of our company, we have the disposal in a landfill that is organized by us. So it's biodegradable, it follows the rules. If it's in the landfill, would it affect the environment? The cap for plastic, fossil, this affirmative has been rejected. Biggest question, important, Yuri has pointed out. We believe that we have to strengthen the chain in reverse logistics. What has been done with Mãe Terra packaging is correct. Receiving the material, having it back, doing the composting, and in the cycle. It's our responsibility. It's a global responsibility, not easy. To pouch Braskens, Braskens material, we have to look for people that understand about it, that have to use monolayer pouch being recycled. So the chain has to be connected. Where it makes sense to do the recycling, okay, otherwise we do the composting. Despite the challenges, low recycling, our role is strengthening the chain to make it work. There's no magic material. I do not see it. There's not a material that will solve all the problems. We have to complement and study much and more, complement more and more, work together, study more. Our partners will have to learn how to do recycling, virgin material, and composting the same plant. It's worth trying. Concerning the labels the client has to identify everything on the label, if it's recyclable or not, because sometimes the product's not recyclable. So the contact with the organism, so it cannot go back to the recycling chain. The end user has to be oriented. This movement can be done. Education is fundamental. Right information, correct information, because as Ellie has presented in the event, bioplastics are with some confusion in the market. And its value, mainly if you consider the circular economy. Question to Yuri. Organic Carvalho asks, PP monomaterial packaging is certified with Reciclex? In fact, I confess I do not have an answer for you. It's a certification that's European. And the focus was on the long chain in this regional area. I may look for this information passed out to you later on, not now. So there are some questions that have not been answered, but we don't have time. Now, Yuri, final remarks, please, to close this panel. Thank you for the opportunity, Emmanuel, Adriana, for the excellent presentations. My message is the view that the world is working to optimize the linear economy over the last 300 years. We have to transform it strongly. We don't have 300 years to reach the new model. We have to be faster, and the best way to do it quickly is via cooperation, breaking barriers, working together to speed up with interaction and cooperation and development. My invitation, if you are interested, if you have the same wavelength, look for us, our contact, Braskem, in order we work together. There is no single solution. One invests in several points. The design, developing, product development, recycling development, mechanic recycling, investment in advanced recycling next year, solutions that are complementary, that will take us to a more circular economy with low carbon. Thank you all for your time and attention. Emmanuel, thank you. Our role is saying thank you concerning the presentations of Yuri and Adriana, spreading the word. We are the base of the chain, and we have to try more and more to manage our carbon footprint. I believe we are a generation that has to go and finish what has been delivered to us. We cannot be linear. Our generation of professionals is like that. We count on everybody. It's watching us. Thank you, Karina and Luisa. Thank you, Adriana. Please, your words. So thank you, Manuel and Yuri. We are relevant players in this scenario. We are part of the chain, and we have to reach the end user, the consumer. Our role is informing information. That's it. Okay, now we close this panel and we show that bioplastics are here to replace plastics in every application. So it's important to inform that plastic is plastic, so it's the evolution of plastic. So the application is showing that plastic is not a villain. Now, Ellen will close and present the next panel. Now, in the chat, you have the link with the formula to fill out with your assessment. You'll receive the certificate via email. Concerning the presentation, those will be available in the website of the event. I ask you to send the formula in order we improve our events. Fourth and last panel. Thus, the moderator Karina. And we have Eventos of Bioplastics and Paula Henrique Cardoso of Polymex. Karina will talk a little bit about the theme startups. Good afternoon again. Luis and Paulo, welcome. Last but not less important panel. We show two startups, disruptive ones with innovation, technology innovation, concerning polymers. To close this event with this panel is very important. Science and entrepreneurship and innovation are part of the plastic chain and bioplastic. Welcome. I hope that you all take this opportunity to listen to these young entrepreneurs. I introduce Luisa Vendruscolo that will talk about Biox 001, that is degradable bioresin. She's a master in administration by USP University, administration degree, and also courses in FGV, more than 15 years of experience in the financing area. And she started the company with Clea Vendrusco, expert in biopolymers, using biotechnology to contribute to sustainability in the environment. Good afternoon. Thank you for the introduction. Thanks, Karina and Lucia, for the invitation to present our solution I'll share my screen. Bioplastics is a company that develops biomaterial. Biox 001 is our bioresin that's degradable. We've been listening that we're trying a solution for pollution problem generated by conventional plastic. Plastic is an excellent material, versatile, several applications, but recycling is not sufficient. Only 1% of the plastic is biodegradable. Reports of Markeplan, a reference in circular economy, presents data like $120 billion with the waste, the landfills, and 40 billion concerning environmental costs. That's not attributed to conventional plastic. So, of course, it alters the price of the conventional plastic with the biomaterial that we are developing. Fortunately, we're changing. Most of us know what's ESG. In Portuguese, ASG, the pillars of sustainability, social and governance. These letters are in the corporate. We talked about it today, talking about carbon footprint, use of plastic, etc. We have information today, as Bruno has mentioned, greenwashing. We are easily seeing the information and checking if the companies are concerned about the impact of their doing greenwashing, just putting a seal. It means we do not we have that as a standard. We talked about standards of product, but we did not talk about the law in terms of education. And there are fines or any sanction. We just concern the situation related to education. So we know that since the beginning of pandemic, the plastic material was considered differently. There is a movement all over the world. First of all, not using the plastic, the disposable plastic. And recently, the UN resolution established in March, so 175 state members representing the new push for circular economy. The document foresees the establishment of the first global treaty against pollution caused by conventional plastic. In Brazil, we see these changes. And so we are debating about it. In this context, Bioplastics started in 2016. We are a biotechnology startup. Our portfolio, we have biopolymers, adhesives, labels, that we contribute to the reduction of pollution. We believe in the use of this technology in terms of environmental sustainability and using renewable sources up to 100% biodegradable material. Biotechnology is applied to environment sustainability. We are 2 partners only, and we have some companies that we consider our partners. What's BioX001, BioX001? It's a raw material. They are grains that are processed, 100% biodegradable. As has been said in the morning, we do not have the certifiers to do the certificate, but in partnership with ESA Polímeros and Unicamp and ESA Maremato, we're able to do the tests and the specific standards of this bioresin, proving that it is biodegradable. It's of renewable source. We have talked about elementary culture. Our renewable source is microbial. It's a different process. So it's clean production. It's potentially recyclable. We have already some tests of reprocessing. And we asked it for a trademark end of 2020. What's the challenge? We wanted to check the first phase, beginning of the biofilm to a scenario of commodities. Plastics are commodity. What's the differentiation? We know that the factories concerning transformation of plastic, they last 30 years. We are not in the area of transformation. We are in the area of development. So we focus on grain development. So balance in order not to require things that would be difficult to obtain. We would have to change the machinery, etc. So we have focused on the transformers. Well, and we're able to develop with Senai the access to experts, professors, PhD people that helped us with the extrusion process, and we developed the bioresin. We had hundreds of samples, and we reached the level of development to do the processing without any need of adaptation, guaranteeing the scalability of the material. It's a film, it's pelletized, and it's a pellet, biopellet. It's the drop-in of the material in the machine. After this characterization, we tested the new biomaterial, biofilms, the simulation, plain extrusion with success. And then in 2020, we were able to complete our product. We did not launch it because the pandemic started, but we were able to help, with the help of Sebrae, to launch a new material, to do the test of application, concerning cast plastic, and also the composing test. injection part is the second form used after extrusion. So Senai and Maramato institution, they helped us in this application. And we are working now on cutlery, biodegradable cutlery. Bioresin can be alterated by biopolymeric matrix. So our business model is developing according to the application. So our focus is on unique use plastic, single use. So sometimes it takes so long to manufacture this chain with non-renewable sources. So the use lasts for 15 minutes when we talk about single use. For instance, cutlery, cups, second level packaging, gloves that we used a lot in the pandemic. Single use is a plastic that, due to the difficulty concerning recycling and logistics and the weight, it's a difficulty to do the recycling. That's why we use the Biox 001 in these products. Talking about the global market, it generates $30 million per year on this focus on cutlery. So this is the result. That's very feeble. It is $7 billion with a disposable in general. And Bioplastics says that the disposal are 1.8% of the market, in a market that is 91 billion of transformed plastic. So the incentive of the players presenting this work, developing biodegradable cutlery. In 2021, we approved our project with the support of SEBRAE that is being developed with Senai Maramato with advanced material. These are the elements of the test. It's a development. Plastic is not simply born already ready. We have to transform the material, use additives, etc. This is the cost of development. We have hundreds of tests that are done, which they used of it. The production of resin, it's a clean process using renewable material. The objective is to use it in the machinery, in the transformers. So it shows this scalability. There's a gain in terms of economy, saving energy, electric energy, and water. And we do not use water in the matrix or processing processes. And so it's in line with the ODS. We look for new companies, new partners for the application, generating flexible packaging or single-use plastics, flexible material or rigid material. They are personalized bioresin, developed with information of the application industry. My partner and I are the head of the business, and we this year had a technician and a PhD helping us for implementing the projects, to implement the projects. So we have Dr. Claire Vendosco, is an industrial chemist with 7 trademarks and 6 requests for trademarks. And Maria Luisa Vendosco does the administration. And we started the company in 2016. We are approved in the process. Supera Park in Ribeirão Preto City. And we have the support of several universities. And we also have Poland companies that help us. Our company is technology as an important startup in the Brazilian country, and we contribute to environment. Last year, we received our award, Innovative Impact and Innovation Award. This is good. It shows us, it gives visibility. People are coming to us, they want to do this transition to bioplastic, and they need this bridge with the plastic transformers. The process is there. Companies normally want a bioplastic packaging, but they don't know how to start. So we are able to understand how to help. This is very good. We have international acknowledgement with clean tech, with visibility to contribute to the companies that come to us. We look for partners using packagings and plastics of single use that are focused on sustainability, and we're looking for investments for scalability, for new tests, and production to commercialize. I think that I covered everything. Please enter into contact with me. I am here for the Q&A, and I thank you for the opportunity. Thank you, Luisa. Congratulations for the presentation. Now I invite Alvin also for next. We'll talk about bioplastic based on industrial waste. Hi, Paulo. Here's the chemist. Here, the Rio de Janeiro is PhD in Universidade Federal of Rio de Janeiro, expert in biodegradable plastics, developing projects in circular economy based on biodegradable plastics. And he has a partnership with Embrapa, many reports and papers, many awards, and international awards. He took part in an initiative that was named Iniciativa Jovem, and he got the award. He is in the Polymex startup in the CEO position. He is focused on the changes in the environment and social welfare. Thank you all. Good afternoon. My name is Paulo Henrique. The content that I will present, I hope it adds anything to the whole and interesting content that you got all this day long. I'll talk about Polynex. So as Helen said, I am the executive director of Polymex. So our inspiration, if packaging in nature are compostable, what do we have to do? The problem is 8.3 billion of tons produced, 9% recycled, 11% incinerated, 80% accumulated in nature. Presently, there are global movements. Helen McCartney leading the circular economy movements, sustainability. So we have global movements. We are growing and we are changing in terms of circular economy. We see the movements some companies are doing, directing to circular economy, changing the material. And we see good news about some companies in Europe, some countries in Europe not using plastic that is derivated of petrol. So, and we are focusing on single-use plastic. The laws, legislation in Brazil are on the screen to use with single use, to replace the traditional bags, prohibition of straws with traditional plastic. And so the objective is circular economy. Besides that, concerning consumption in Brazil, we see the government and private entities with some movement. 37% of Brazilians, 37% prefer the sustainable companies in Brazil. So it's important. 68% of the consumers after the pandemic are more responsive to sustainability. And also concerning the stock exchange, we see the rates, the products that are in the circular economy are higher, with higher value. And so we are still in the pandemic process, but there was a boom of movement. And we know that some consumers should carry on with the new habits they acquired. Global and national movements. Bioplastic, the plastic of the future. Value proposal. Replacing the hazardous plastics and re-educate people in terms of environment. Biodegradable plastic, natural plastic, using in agro-industry waste, biodegradation between 7 to 180 days, replacing the PE and the PP plastics of petrol, 55% of the market, also the PS, polyethylene. So the PNB can be used in packaging and on the disposable. PNB degrades in 180 days and it's manufactured biomass, and it passed by the transformation industry. And after the use of this material, it can be collected and taken to composting and generating fertilizers, organic fertilizers can be taken to that. What are the competitive advantages of PLB? Biodegradation in up to 180 days. And we also have our own technology already branded. So 100% renewable and biodegradable, does not use derivatives of petrol, and it can be used as fertilizers after natural composting. So we are integrating the circular economy, reducing the carbon footprint, and we improve the indicator in terms of sustainability, reducing the impact in landfills. So we do not alter the chain in the transformation industry. So these are all competitive advantages of the PNB. Presently, we have many stages of the product already ready. The PLB that you have on the screen is the product concerning cutlery and straws. It's single use, disposable, and we also developed the straws with several companies. One of our clients was interested to help us. And presently, the plastic global market has a 30% rate annually, representing US 324 billion. Represents 40% of the global market. So it's very special. There is a big change. It's a transition period. Plastic is important in many chains, in many applications. For solutions that we are referring, it's important to do this transition. Business model, B2B, model based in P, D, and I. Research, development, and innovation. So we develop a design specifically for a certain demand. So it's the personalized production, because sometimes you have to outsource the production in B2B. There's a direct sale of resin to the manufacturers of plastic products. It means third parties involved. And so we have 4 trademarks already prepared. We have a partnership with DKFZ Polymex, and we have a material based on the research of the German Cancer Research Center and the Helmholtz Association, and we developed new materials for them. Talking about our conquests, our company is a spin-off in Rio de Janeiro district. And so Boyne and Lucas were the founders. So it's part of the Federal Institute or derived from it. And we took part in more than 100 projects in 6 federal institutes, and we are national champions. Like that, we take part in the integration of business of high impact in the economy. So because we do the acceleration, the capacitation, internalization of our performances. Besides that, we carry on with new conquests. We had the innovation for the industry call duly attended. So we received 1,135,000 in resources to develop a new product that we had to do between 2019 and 2021. We did the access to the structure of ISI biosynthex with Senai uncertificate, and we developed the analysis of the PNB and follow up the qualified team. Another conquest. We got 190,400,000 and in 2022. So, sorry, 190,400. So our team, executive director, we had the CEO, senior CEO, and the executive director on the screen, Domingos Jafilice and Paulo Henrique Cardoso. So they focus on the executive part. I do administration. I work on different materials in the chemical aspect. So my profile is more technical. Besides that, we have the technical direction, Luan Campos and Lucas Correia Batista. They are graduating in chemistry in Rio de Janeiro and in polymeric, focus on polymeric material. Our cooperators, it's a team that's diversified and it's important in the company. We have Gabriel as commercial man, Luan and Juliette doing the social media. Luan is a designer and Juliane is the manager of the social media. We believe that's important to have that stage because it's part of the chain and it's in the transmission stage. We have a consulting team, which is very important. They are directors, they help us, they are consultants in marketing, finance, chemical engineering, and technology. They help us to align the strategies. This is very important for the development of polymer. Presently, as you see on the screen, we have the validation of several tests, and we are ready to do this. We're looking for financing for the industrial production, for the scaling of PNB. Polymex is in line with other companies in terms of sustainable communities, with the objective is being sustainable, protecting the sea, marine life, the consumption and production in a responsible way, and acting against the global change in terms of climate. In terms of climate, we have supporters helping us, and we are in Rio de Janeiro state, have the support and networking with other companies that are also innovating. So it's a chain. It's very strong for our growth. So thank you very much. We are with our contacts on the screen. You contact us if you feel like. Call us just to chat a bit. If you need anything, just contact us. Thank you. Congratulations for the project. Thanks for your participation. I invite Karina to lead the Q&A and do the final remarks. Congratulations, Luisa and Paulo, for the presentation and projects and initiative and the scientific work. You know, it's a lot. Looking for investments, continuous search for investments. It's part of the process of innovation, isn't it? No. Luisa. Gustavo Henrique Moraes asks, Roberto also asks, what's the origin of this bioresin? What's the polymer? Is it a blend? Does it have additives? Or it is a waste combination? This is the differentiation of our bioresin. It's a biopolymeric matrix composed by bacterian and non-bacterian biopolymers. That's what I can tell. A question from Leda. Nice to have you here, Leda. Your presence is very important. All the questions are important to both of you. First is, materials, do they have approval of contact with food? It's one question. The materials that are with the approval to be in contact with food. Paulo, please. Contact with food. In Polymex, in this sense, Anvisa has a list of material. All the materials are used according to the use permitted. Maybe it's the same thing. We sell the resin, and who has to have the certification? Those that will do the transformation of the material. In Polymex, we, in order to have this approval from Anvisa, we do a migration test. So to be approved by Anvisa. So it's important to have this migration test, to have this approval. Of course, we have to inform our clients. That's it. Bioproducts, Bioxid 01. It's in this sense. We have the certification, non-toxicity of the material. But for the application, it's important to do this co-development because the application tests concerning the final material, they are done after the application. Biodegradability of the product, in our case, the cutlery. So this co-development is very important to know. So bioresin does not need the certification, but we are conscious that this biomaterial that is used is according to the characteristics required for the use concerning food. What are the agro-industrial waste used? One is the color of the material. The disposal was a bit purple because we use açaí. So it's açaí pulp in Pará. So we have a high amount of material and we use it. So we use this type of waste. It's the açaí seed. So we use the açaí seed that is very much found in the northeast region of Brazil. And we can also use mango stone. So we can reuse the material. It's very important. Your work is very important. You consider the design of the product, the origin of the raw material. You produce a product, so use that can be sent to composting and be transformed in biomass again. Going back to the cycle, closing it, biologically speaking. Congratulations for your work. I have no other question. Anything else you want to ask? Final remarks? It's all okay. If you do not have another question, final remarks. So I'll talk about the panel and the event. I pass the floor to Luisa. Okay. Very enriching in terms of information. Thank you for the opportunity. And I'm very happy to have a very pleasant day with many companies, diverse companies with innovation in terms of solutions. Have the opportunity to present among them. We're starting, we are only 6-year-old, so we are in the same level of Braskem in this forum. It's something important we are contributing to. So everything that has been mentioned here concerning education, concerning awareness of changes, that we are in line here with good results. We are a startup, 2 partners, but the way we take, the journey we take, we have good projects, more people are taking part in our solutions with higher projects, as Paulo has said, looking for funding to have new results and better results in terms of production scale. Thank you. Count on me for next opportunities. This is our work. The hardest part, we already did. We know the way. Now, every day we have to be aware, see what can be done, which are the difficulties, the bottlenecks, carrying on, never giving up. My contribution, our contribution of the company, everybody is so engaged, and we want to contribute to a new classification of biomaterial. Thank you. Paulo, you now. 3 things. First, thank you very much for the invitation, taking part in this event. Very enriching, very good. I learned a lot here today. It's very important. Learning has to be a constant item. New information, listening to other people. As Lisa has said, it adds value. We are taking the right journey for a solution that in the long run will be better for everyone. In terms of health, life quality, for the environment as well. That's what I have as my goal. And it's important how big this market is. Solutions are arriving. People dedicated to this market, having alternatives, it's important. We have to look for it, having it more and more in line. I think it's important to say that when we are at university doing lab work or scientific work, we see that many projects stay in the drawers. Take it off the drawers, deliver it to people, deliver solutions. How to educate, not leaving it there, just publishing it in a paper in a journal and not doing anything about it anymore. If you don't use the paper for anything, what's the purpose? I'm using for the Mac what I studied, what I did not keep in the drawer to develop our material. It's important. So thank you again. Congratulations, both of you. But we have no time for other questions, so we see that there will be other chances for your presentation and answering the questions in the future. I thank you again on behalf of Markeplan, the team, the organizers of this event. And I will not mention the names, but I know that there are people that make things happen. All the lecturers had the help of the organizers. Ellen, thank you. The Master of Ceremonies that helped us today. And Lucia, the organizer, looking for speakers that could take part and choosing the themes, real success. Markeplan, for sure, is pleased with the team, including the board. Thanks for the opportunity to support a so enriching forum in content, education, information to the general public. It's the general public that is calling us. We thank you, the audience, that is following our program. So pay attention to information on our website. There is no single information, and bioplastics are here to stay. We have innovation. As plastic started over more than 1 century, we did not speak about recycling, now we do. So composting bioplastics, we're talking a lot about it. On the 1st of May, from 1st of May to 7 is the first week about composting in Brazil. So it's changing, it's going ahead. As João Carlos said in the morning, it's an emerging industry as the bioplastic. The moment is changing bioplastic and guaranteeing the next generations. More scientists like you bringing solutions to us, contributions to the society, to the economy and environment. Thank you again. Now our Master of Ceremonies. Thank you, Karina. I thank you, everyone. We are closing our event. We thank our speakers, moderators, technical support, and mainly to the public that spread technological information about bioplastics. This event will be available on YouTube. I invite Luciavalverdes, Director of Markeplan, to officially close this event. Good afternoon. Thank you very much for your patience. The whole day having information. It's very tiresome, but everything that has been presented is very productive. People liked our event via YouTube. We've seen that the attendees were happy with the content presented. So I thank all the lecturers, the speakers that were here with us. And of course, I also have to thank our supporters, moderators, sponsors. Without them, we cannot do any event. We depend on the structures. And just for your information, we had 1,800 subscriptions. So 300, 400 online people in the morning and more or less the same in the afternoon. We are happy to do this first bioplastic in Brazil. It will be the first of several. We'll be here again next year. Congratulations, Ellen. That was brilliant in her work. Karina, that helps us as always. And just to close, I would like to invite for the next event in June. It's an international symposium on plastic that is over the last 30 years happening. It's an excellent event focused on injection and circular economy and digitalization to be presented 28 and 29 of June in Dayatuba. If you're interested, just visit the website. And subscriptions are open. So thank you again for your presence and till next event. Thank you.